Welcome to APEC. It's June 14th, 2025, and I'm your moderator, Tim Ventura. I want to thank everybody for joining us on today's call, along with everybody watching us on YouTube. I am really excited. We've got some amazing conference presentations for you today and a lot of news to share as well. So starting out, Chad Wanless will be explaining UAP Warp Drive signature detection. Then Jennifer Nielsen is going to be discussing testing a new model for calm gravity with navigable spacetime and tunable wormholes. And Orestis Lazanakis will be discussing research into UAP and implant samples. We're also going to hear updates from our lab partners, and we'll be finishing off the event with open discussion by conference attendees. So I have some quick updates for you guys. Again, this is the busy time of year. I'm really excited. There's so much amazing stuff going on, not just with APEC, not just with emerging propulsion, but just in this larger emerging technology and space sector as well. So starting out here, today's event is on StreamYard. We're broadcasting through the Alt Propulsion YouTube channel. We're also out on, Facebook, LinkedIn, Twitch, Twitter, and Instagram. That's just today. So we are multicasting. That is super exciting. You can ask questions on YouTube using the live chat feature on the right-hand side of the page. We can put those up on the screen. Sometimes we do during the later presentations. We can also ask those to our presenters depending on time constraints. So I wanted to mention that. And also, you could always view conference replays, details, and speaker info on our website at altpropulsion.com. That's also going to give you a good idea of up and coming conferences. And if you want to go back and look at past conferences, you can watch any of them. I think we're on 73 or 74 now. So we've had a lot of these, all of the biggest names in the emerging propulsion space. Many of the biggest names in the UAP space as well, focused on science, technology, innovation, and hands-on. So one of my theme words for this year is doing the work. I'm trying to focus on the folks who are doing the work because that is where the rubber meets the road. Okay, so in terms of updates since we last met, I got back from the Scientific Coalition for UAP Studies 2025 conference in Huntsville. I was there last week. A bunch of notables. I got some great photos. The big one was Matthew Sadagas, Dr. Matthew Sadagas, held up the arts parts sample on stage for the entire world to see. He had a box with APEC labeled on it with the sample that Mark Sokol and Jared Yates have been diligently researching. So that was really exciting to see that. I got Flickr photo galleries for the SCU event. I did not get conference photos. That was prohibited this year. I did get lots of candid shots of the folks who were attending. And I would suggest if that's something that's an interest area for you, consider attending next year. Visit their website at explorescu.org. I will have videos coming soon. I'm going to run through these very quickly. So I also met while I was in Huntsville with Glenn Tony Robertson, who has been a longtime APEC contributor, former co-chair of the ISNPS STAFE conference, and founder and chair of the later SPECIF conference. Tony was one of the original NASA team working on superconductive gravity modification. I shot some video with him. He had updates for us on his research. He had some historical corrections, things that history just has incorrect. And he also had some updates for us on the Ning Li story. I also interviewed another fellow at the conference who was actively researching the Ning Li story. And so I don't think that there are any big mind-blowing revelations there, but what I've been trying to do is put more of the pieces in place, clear up that story where I can, and probably most of you have read the Huntsville Business Journal piece on that, which I think brings a lot of folks up to speed. So while I was there, I also met with Chance Glenn, who is testing space-time distortion at his lab at Alabama A&M. So again, very, very exciting. I got photos for the SCU, for Tony Robertson, and for Chance Glenn. I have video interviews coming up with both of them on the Alt Propulsion YouTube channel. And Chance Glenn and I just did a podcast interview a few days ago on my own personal interview channel, Tim Ventura Interviews. So if you're subscribed to that, take a look. And he talks about what he has been doing with space-time distortion. Okay, so thank you for your patience with the announcements. Just about 5 minutes. I am excited. I want to bring on Mr. Chad Wanless. Chad, welcome, sir. Okay, and you were muted.
There we go.
Okay, there we go. Yeah, Chad, before anything else, I want to thank you so much for presenting this. I think a lot of the attendees saw our interview on my channel, but so basically what you're doing is you are analyzing old photos and video, looking for UAP warp drive signatures. And that is something that a number of physicists have claimed should exist. You're saying, okay, if they're using warp drives, there should be photographic and video evidence. You're one of the only people who's taken a serious look at this, and the work that you're doing is impeccable. So thank you so much. I'm going to bring your slideshow in, and I will hide in the background and take it away, sir.
Okay. All right, I'm going to share my screen now, actually, if that's all right. Tell me when you see my screen. There we go. All right, so my presentation is UAP Warp Drive signature detection, and I'm detailing 5 new observables. These are on top of the original 5 as detailed by Luis Elizondo in his book, Imminent. I am a volunteer member with the Center of the Scientific Study of Atmospheric Anomalies, or CISA for short. It was started by a fellow named Rob Freeman. One of his famous videos is an orb that was filmed in Squamish, British Columbia, not far from where I grew up, actually. So we have the original 5 observables, not including the bodily effects: anti-gravity lift, hypersonic velocity, sudden acceleration, low observables, and transmedium travels. And in my book that myself and my co-author, Professor Dave Palachuk, published earlier this year, we've identified gravitational lensing, leading edge vapor cones, oscillation blur, gravity counterbalancing, low velocity disk, flight configuration, and saucer-like skipping motion. So gravitational lensing is where, as the UAP is moving in front of an object, the background gets momentarily deformed or warped. The center image is an animated recreation of a black hole passing in front of a galaxy, and on the right is a photo from the 1950s showing a UAP in and of itself being affected. Leading edge vapor cones is something new no one ever expected, including myself. I first noticed it in the Aguadilla UAP video, and then I found another video from 2023 showing the leading edge. Oscillation blur is where a UAP is turning its warp drive on and off rapidly for various reasons. Counterbalancing is when flying at a low speed, a UAP has to counteract Earth's gravity and provide forward momentum, so it will fly tilted, similar to how helicopters fly tilted. And saucer skipping motion is where a disk or some other UAP is flying horizontally, but it's moving up and down like a saucer skipping across water. So a little housekeeping information. This presentation is solely the opinion of the presenter and does not represent the opinion of past or current employers. Fair use notice: some of the videos, photos, and artwork are for educational purposes, and at no time did I ever receive any classified information for creating the content. I have published 1 book, and I have a 2nd book, Missing Time 2, about abductions, coming out mid-summer. And what started it for me was this video. I found it on the Angry Astronaut podcast, and it was a Saturn-shaped UAP flying in front of clouds, and I noticed the background objects were moving. I called my friend Dave and said, take a look at this. Do you see them? And he says, yes, I do too. And this is where our research started, right here on this video. To give some background context about gravitational lensing, let's first dive into the Alcubierre shape function. So that's his formula at the bottom. I created a scatter plot using Excel. So what it does is it shows, you take a point in space, you put it into the formula, and it tells you how far away it pushes that point in space away from the center of the warp drive, or in the case of the upper part, pulls it towards the center of the warp drive. Now there's two downward pointing arrows. I will explain those in a minute. But let's first describe what is gravity. We need a simple explanation so everyone can understand. The best I ever heard was take a block of wood, drill 2 holes through it, thread some strings or rope through it, tie it to the end of a doorknob, and then pull it apart. That block of wood will move away from you and towards the doorknob. The doorknob represents Earth. The block of wood is any object in Earth's gravity, and the strings represent the spatial warp. We all know that large objects warp space, and it creates this lever effect where every molecule in your body is simultaneously applied this lever effect, pushing you down towards the ground. That's how gravity works. So this in mind, on the left-hand side, the Alcubierre Warp Drive actually has 2 backwards or downwards facing V shapes. So there was a disconnect between the upper and the lower hemispheres. I had to create and find an elastic formula that's down in the center, and it allows the upper and lower hemispheres to curve back towards each other. It is in that spot, in this wine decanter shape, where an object or a vehicle can exist and will experience upward or forward gravitational acceleration. If it's anything below it or above that area, will either be pushed down into the top of the disc or pulled off the bottom and pulled away. And because this is a circular wine decanter, if you're going to build a vehicle with the maximum internal space for engineering space, cargo space, passenger space, scientific study space, you're going to want to build it as a disc-shaped object, which means it is absolutely no accident that UAPs, by the vast majority, are disc-shaped for medium-sized UAPs. Now, this is the next part of this and the final part of the scatter plot. I've applied a compression color chart to it. So the warp bubble is round, but inside where it counts is wine decanter shaped. But you can see here in magenta, just above center, is the high compression zone, and red below that is the expansion zone. Now, let's get into what is gravitational lensing. So here's an example from astronomy. Between the Earth and a quasar far off in the distance is a galaxy. The galaxy is going to pull space in towards itself as light travels from the quasar, which the light normally going away from us gets bent back towards us. And what you see on the right is an Einstein ring. You can see the center of the quasar in 4 different locations. Now, at the macro level, instead of astronomical level, if a UAP, in this case a dark cube, is warping space as its form of propulsion, light passing through that curved space will also bend slightly. And in this case, the same pattern occurs where light going above and below are bent back towards an observer. The observer is going to see, on the left, a dark cube inside a round sphere, a transparent sphere. It's not a real sphere, it's an Alcubierre warp sphere. So it's not glass, it's just spatial bending causing the light from the background to appear as if it's in a clear sphere. All right. There are three types of gravitational lensing that I've identified: momentary background deformation, radar return echoes, and deformation of the UAP body themselves. So the Aguadilla UAP video was first identified as having gravitational lensing by Kenneth Knuth, and I found his slides from a presentation back in 2021. In this particular spot, the object was passing in front of the tarmac, in front of the lines, the painted lines, and you can see row A is the original FOIA release video. Row B is a computer enhanced contrast and denoised. So you can see the background lines are actually momentarily disappearing or warping as it moves in past. The next major one is as it's passing in front of this building, which is dead center of the screen. Column A is the original FOIA, column B is contrast enhanced FOIA, and column C is a computer enhanced and denoised. And in the dead center, and over here, you can see as the UAP is traveling in front of a linear feature of that building, it actually curves down. The building curves down momentarily. And you can see it a little bit better here. And this spot here in B looks exactly like the gravitational lensing simulation we had seen earlier. Now, there's this argument that it was a object, balloon, or sky lantern in parallax. But here, there's a set of trees. You can see it passing behind in the animated GIF. And there's another blown up example of it changing the background as it moves past and in front of. There's a dark line feature that clearly deforms. So Arrow in November 2024 had said this was a balloon or sky lantern. Well, what do balloons look like to an IR camera? A fellow named James from James Drones Thermal had presented his finding. He took an IR camera, put a latex balloon out, and you can barely see it, and that's with the camera 5 feet in front of the balloon. And there's two different color formats, B and C. Now, Dave Felch had done another experiment where he released a latex balloon and filmed it using the same camera that was on board the Department of Defense aircraft over Aguadilla. And the little red arrow points to where the balloon is, but if you didn't point it out, you wouldn't be able to see it. Now, another type of balloon is mylar balloons. This is the other type. It's an aluminum, and it absolutely reflects everything around it. It's a perfect mirror in IR. Mick West was attempting to debunk the rubber duck video, as you can see on the right, saying that when filmed from above, he filmed this from his balcony looking down on this happy birthday balloon. And the balloon looks cold because it's reflecting the cold sky. And there's a small part underneath it where it's underside of, on the underside, it's reflecting the lower ground. So a mylar balloon would appear cold as a bright white, not hot. Now, the other option was, the other thing they said it could have been was a sky lantern. Dave Felch also filmed a sky lantern, tied it down to his driveway using an IR camera. You can see this dark blob. This is the closest thing to what the UAP, the Aguadilla UAP, looked like. However, there's an anomaly issue. I've identified as the object passed in front of pretty much every darker background, it displayed this cold cloud, either in front of or above and trailing. And at first I wasn't sure what it was, but I realized later that it was a vapor cloud being formed. So because Arrow said it was either a balloon or a sky lantern. They didn't bother looking at what do latex and mylar balloons look like, which means they did enough work to confirm what they thought it probably was, which means they were falling for confirmation bias. I won't read this. Anyone can pause this and read it if they feel like it. But it's especially important to point out people are especially likely to process information to support their own beliefs when an issue is highly important or self-relevant. Now, there is one other argument that has been used to debunk the Aguadilla, and that is when an IR camera is filming an object and it's zoomed out, you're going to see this white line and a dark outline, or inversed. In this particular case, white is hot and cold is black. And the closer or the more the camera zooms in, the more clear this object becomes. Now, the same thing happened with Aguadilla. The first two images, A and B, were filmed at a distance with it not magnified. The value of 135 was the magnification. You can see the dark round object with a white outline, and there are some objects on the ground that are also dark with a white round outline. However, when they zoomed in to magnification 675, the closest it came, you can see in number C here, or letter C, it was just pure dark black, no outlines of any kind. And D, as it passed in front of a road, you can see that there's this cold area forming behind it, like it's leaving a trail of vapor behind it. This does not look like this. So this argument that it was a pixelation issue goes away because they did zoom in, and they zoomed in enough to identify with detail. So what are leading edge vapor cones and how do they work? So this is a zoom in of the Aguadilla. I color coded it to emphasize what is hot and what is cold. And you can clearly see this vapor cloud forming in different locations. So essentially what we need to understand is, going back to that spatial compression above the UAP, let's use a simple example, the TARDIS from Doctor Who. It's the size of standard police blocks, 192 square cubic feet, but the interior is at least 10,000 cubic feet in size. So this is a relative thing. When a volume of space is compressed, the interior of that volume still maintains its original size. However, to an outside observer, the volume of space and its contents will appear much smaller. Now, if the door was left open and a speed wind of 100 miles per hour blew into the TARDIS, the air would find itself in a much larger volume of space suddenly. This would cause rapid decompression. When air is decompressed, it cools rapidly. Cooled air causes vapor to condense, and condensed vapor forms visible clouds. So this is a diagram of what the Aguadilla UAP was doing. As it was traveling, its spatial compression was above and slightly left. That spatial compression was moving through the atmosphere at about 100 miles per hour. Air that was in a pocket of space, let's say 1 cubic foot in size, suddenly finds itself in an open space of 100 cubic feet. It'll rapidly decompress, creating a vapor cloud. It's kind of similar to the vapor cones you see on aircraft when they're traveling between 0.8 and 1.2 Mach, but instead of being behind the craft, it's actually in front of the craft. So I'm not the only one to spot this. The Skywatchers recently have released some of their videos, and they noticed it as well. And they stated it appears there are some kind of cloud or vapor around it. And they shared one example of it, but in an interview, one of their leaders was saying they had seen it in multiple videos. And then this is another example that came out just last month. It was filmed in Perth, Australia. And there was this glowing green-blue orb that was flashing on and off, leaving a vapor trail behind it. Everyone was looking at it, commenting what could be, but since leading edge vapor cones was not known publicly. Everybody was absolutely clueless as to what it could have been. Okay, there are then radar echo returns. So we have been talking with the Tedesco brothers, and they have been using their Nightcrawler Mobile Research Lab. They were able to identify and record 14 examples using radar and video or photos of long echo delays and unexpected field echoes. This is another form of very solid evidence, but it's going to be hard to debate exactly what it means. So here's an example on the right of one of the radar plots. So I've circled the boat lower center, and there's a second boat showing up at the extremities at the top. The boat's showing up twice. Why is it showing up twice? The reason is gravitational lensing. The radar sends out a signal A, which bounces off the boat B, which spreads as it comes back. It comes back normally along path C, but it's going to bend around the spatial compression around the UAP, which is above and between the radar and the boat. So it's either going to bend below and or above through the spatial warp and back down to the radar. Basically, the radar sees the return twice, so it plots it twice. Now there's a second plot on the right-hand side circled in E. This is what they call a long delay echo. This was approximately 1 second of returns. Now, just so everyone knows, each radar device sends its own coded signal out so that if two or more radars are tracking the same object, they don't confuse themselves. So it's receiving its own signal back multiple times along E, path E. And C at the bottom center is where the UAPs were located in this photo. So we're not exactly sure why it was receiving it multiple times, the same signal back. One possibility is that the echo returns were somehow orbiting or being caught up in the UAP's spatial warp and then returning to the radar. Now, this is, we need to go into field calibration, because this is something that skeptics will ask is, how about calibration? Was it calibrated? The answer was yes. On the right-hand side, they actually went out, found a buoy at sea. Now, buoys have a transponder on them. When they receive a radar, a marine radar, they'll record that code and send it back multiple times. So you see this long track on the right-hand side in image C. This is done to highlight the fact to a captain of a boat that there's a buoy out at sea, please don't hit me, is essentially what it's saying. Because otherwise, it would be a small blip, it would be barely noticeable. Now, here are several examples. The bottom right is the buoy example, and the top right is another example taken. The quote on the left is from their paper, but essentially this UAP was returning multiple blips, and it was intermittent blips over a period of, it was a short period of time, but it was multiple returns. In this particular case, they had actually pointed the radar up away from the sea, and this is one possibility that might explain why it was seeing its echoes return multiple times. Again, the radar may have got caught up in the spatial warp and then returned multiple times. So this is an example of the buoy versus the UAP. There is a distinct difference. Now, why could radar waves get caught up in a warp bubble? This is one possibility. There's another one I'll explain in a minute as an alternate explanation. But light is a high energy and a small electromagnetic wave, where radar is low energy and a large electromagnetic wave. So it's the combination of the low energy and the large wave could allow it to orbit around in the warp bubble before it escapes. So is there another explanation? There is, but let's first examine the 2004 Tic Tac incident. Commander Dave Fravor noted in a podcast, there is a little signal that shows up in both the images. The left is the visible light camera, and the right is the infrared camera. 99.9 range 99 was the signal error message he was describing. This message is very clear and distinct. This says that the radar is receiving multiple pings back, which is typically, and the other thing that we did not get from the release was the radar plot. We only have the video, we do not have the radar plot. Typically, this 99 is when someone's actively jamming, which is going to look similar to the radar return of a buoy. Now, why is that the case? Well, if you don't want to be shot down and you're an adversary and a radar signal gets sent out, A, hits your aircraft, B, your aircraft records that radar ping and returns multiple of the same radar pings in C. What that does is your adversary cannot tell how far away you are. And that's important because radar-guided missiles don't actually strike the aircraft. They blow up beside it with shrapnel. That's how they take them out. So if you can't tell what the range is, the missile can't strike you. Now, possibility number one with the Tic Tac is A, the radar gets sent out, B, the radar ping arrives at the UAP, but because of the spatial compression above and below, the space is different. So the upper section is a shorter path than the lower section of the spatial compression and expansion, so it returns earlier. So C, you get 2 returns back. So the computer might have seen 2 returns and go, oh, I'm being jammed, and give the signal, give that error message. Possibility number 2 is the radar signal comes out, the spatial warp and orbits around, and you have multiple returns coming back, similar to what was shown with the Tedesco brothers radar plots. Possibility number 3 is the Tic Tac received the radio signals, recorded them, and returned them back because it didn't want to be shot down by a radar-guided missile. That's a big leap, and it means something really intentional. What this means is all 3 possibilities, irregardless of what they are, means that if any one of these is true, the Tic Tac was a manufactured object, manufactured by someone with intelligent design and an intent to, in the case number 3, intent to keep a radar from detecting exactly where it is in the sky. Now, debunkers, and Neil deGrasse Tyson was the first to say this in a podcast with Joe Rogan in 2021. We don't even know if the Navy calibrates its sensors the way we calibrate telescopes. Well, is there a calibration issue? That's what he's saying. The answer is we do know. Declassified manuals published online. He never bothered to look them up. The 99 error message is a hard code fail value indicating that it has received multiple returns of the same code it sent out. This is not a possible calibration issue. Some other error message would have come up if it was a calibration issue. This is clear and distinct. It is receiving multiple returns from its radar pings. So how does calibration work within the Navy? Aircraft radar is calibrated when it's turned on. It takes 2 or 3 minutes when the aircraft is turned on. The at-FLIR pods are calibrated every time they're turned on. Shipboard radar, they are calibrated daily, multiple times a day. Why? Because people's lives literally depend on these functioning systems. If radars don't work, people are not going to make their way back to the aircraft carrier, and they will have to ditch and sea, or some other catastrophic event could occur. So Neil deGrasse Tyson had, I want to bring this up and point this out, he'd chosen to debate creationists defending evolution. Now, when he wrote about that, he said, the good thing about science is that it's true whether or not you believe it. The thing about the Navy and their calibration is, the good thing about the Navy is that it diligently calibrates whether or not you believe it. Another thing he wrote was, check your facts before making claims. Neil did not check his facts before he made his claims. All right, gravitational lensing number 3, deformation of UAP bodies. The earliest photo I could find showing deformation was Hope, China, 1942, long before we even knew what UFOs were. You can, in the blow-up, you can clearly see the left-hand side of this disc is pushed in and upwards. There's a 1952 photo from Passaic, New Jersey, taken by George Stock. It shows here, there's 5 photos, I'm showing 2 here. A on the left, and I've blown it up for C. You can see here clearly that the upper dome is tilted and offset to the right, and then also the disc itself is thicker on the left and thinner on the right. And then for comparison, when the disc is tilted away instead of perpendicular, it is symmetrical, and there's a reason for this, and I'll get into that. And it's got to do with low velocity tilted flight. So here's an example from Rex Heflin, 1950 photographs. You can see it on the right hand side. And the reason why it's tilted is to do with the flight control. What I've taken here is, on the left hand side, A is the Alcubierre Warp Drive, and I placed a smaller warp drive inside and below the larger warp drive. And what it did is it increased the warp field on the left side, which will cause it to tilt and move up to the right. So in sample C, that expanded warp on the left-hand side will allow a UAP to counteract Earth's gravity, yet still have a slight forward momentum to the right. So this is exactly how it would function, exactly the same as a helicopter at approximately the same speed. And you need at least 3 smaller warp nacelles inside the major warp nacelle. Now, there is a paper that was published on the discovery of micro warp bubbles. Now, the paper shows that someone has actually created an actual functioning warp drive, but it was at 4 micrometers in size. So they proposed the next step was to create a daisy chain and see if it would increase the warp signature. So lower left is the a plot output showing that when you do add them together at a very close distance, the warp bubble does increase in size, but its strength decreases with every additional one added. However, in C, top right, if you create multiples of these warp bubbles in a cone shape, not only does it increase in size, but the steepness of the warp increases as well, which means if you turn on and off the outer warp bubbles in this configuration, you now have throttle control. So how does this work? If you create a large cone shape of micro warp bubbles, a couple of billion inside of something, let's say 6 feet tall and 6 inches wide, you could put that in the upper part of a disc. Now, for flight control, as I mentioned earlier, you're going to want 3 smaller ones down below. So you put them underneath on the underside of the disc, and now you've created not only micro warp nested bubbles, but they have macro warp nested bubbles. So you turn all four on. The lower ones you turn on slightly. It creates a warp bubble that encompasses the entire craft. And then for flight control, you would adjust the lower ones up and down in strength to increase your speed or tilt and essentially achieve your flight control. Some people may see this and recognize this particular configuration of warp nacelles. And that's because this is Bob Lazar's sport model, how he drew it up, how he diagrammed it. What I've basically shown is Alcubierre's math shows what Bob Lazar reported is correct and accurate for that theory. The difference is he used waveguide and gravity amplifiers. The reality is all four are gravity amplifiers. So tilted flight control using nested warp nacelles, using the sport model configuration. You can see here on the left, Paul Trent's photo, tilted. It is in line with the camera. I've placed the warp bubble and the scatter plot over top of it. You can see down here, center line is here. This protrusion up the top is actually the central warp nacelle. And because there's two spatial contractions above, the light from that warp nacelle is being bent towards the left and leaning slightly. And you can also see a slight bulge on the lower right and a slight compression of the disc on the upper left. Same thing with Rowan photos from 1953. It's similar, if not identical craft. It's a little bit of a more detailed. The upper warp nacelle, again, is tilted and even farther to the left, and then you can see a bit of a bulge on the right versus the left. The Trindade photos from 1968 also show the same thing in two of the four photos. Every photo shows tilted flight. However, A and B show a compression on the right-hand side and an expansion of the disc on the left-hand side. C and D shows that it's symmetrical, which means that it was probably descending at the time and it was not creating an asymmetric but a symmetrical warp bubble at the moments of those photographs. Now, some debunkers say this is proven hoax, this thing, but it's not. Some 50-odd people, I believe it's 48 people, all witnessed it. It was investigated by the Brazilian Navy and for 2 years, and they concluded that it was not a hoax. All right, so we have a new observable benchmark, the Heflin standard, I'm calling it. Now, he took 4 photographs. There have been a couple of papers evaluating his photos. The craft was always blurred, yet the background objects like the telephone poles were crisp and clear, and they did not know why. The reason is warp oscillation. And just straight looking through the warp bubble itself will cause a slight blur. But if the warp system is turning on and off rapidly, you're going to see it more than once. And then the lower right-hand side, there was a smoke ring that was photographed and the 4th photo, and no one actually understood why until I realized this was a vapor cone that was split as the UAP passed through it as it was rapidly departing. Now, I know there was oscillation going on here because in the 3rd photo, it's not a duplicate. It looks like a double exposure, but it was a Polaroid camera, which is not capable of creating double exposures. So highlighted in green is the UAP in its original configuration not being affected by the spatial warp bubble, and then highlighted in red is this drawn out, warped, smeared version where it is being affected by the warp bubble. The photograph was taken and the aperture was open long enough that the warp drive switched from on off during the capture of that aperture opening. So why would there be warp oscillation? Well, think of it this way. if the object looked warped to the camera, the pilot inside is also going to see the world looking warped. So if he's looking out the window and the warp drive is off, it's going to look like it is to the left in A. But if the warp drive is on, space is going to be compressed, and everything's going to be shorter, and he's going to see more sky. Now, this is really important as a flight safety issue. If you oscillate the warp drive on and off, say 30 times a second, and you're using a camera instead of actual ports, you can turn your camera on and off alternately with the warp drive, so you can see the outside world in real, unaffected space, and you don't have to worry about, am I pointing the correct direction? So, if this was hoaxed, how did Rex Heflin know about Alcubierre's warp drive theory back in 1965? And how did he know to create a smoke ring that wouldn't be identified until the publication of my work in 2025? So here's another example of warp oscillation, and this is that disk from Saturn-shaped disk over Columbia. On the left-hand side, you can see there's an edge of the cloud that is moving every other still image, every other still frame. And on the right-hand side, there's an upper anvil that is moving every other frame. Now, there's a couple of possibilities. They may have been oscillating to view the aircraft to avoid a collision, or it might be a stabilized autopilot function. Gyroscopes would not function in a normal, well, I understand say normal, in an Alcubierre warp drive system. It would be screwed up by that. So if you turn it on and off, and you use the gyroscope during the off segment, that'll give the computers the real world orientation. So it may have just been autopilot that was identified here. So the last one, saucer-like skipping motion. Kenneth Arnold, June 24th, 1947, saw 9 discs or disc-like shaped objects. In this case, he had it drawn up, looked like a boomerang, but he described them as saucers skipping on water. And K4 Oklahoma News in February 2025, by sheer happenstance, they had a webcam looking out for the weather, and a disc was, or a yellow object was seen moving across the sky in this, and I traced it here in this odd pattern. And the weatherman actually walked up and pointed it out. Now, they did have some quote unquote experts look at this, and for safety's sake, they said, for comfort's sake, they said, don't worry, folks, it's not aliens. Well, we can't tell who's in that, but what we can say is that was an Alcubierre warp drive system. And there's a reason why these craft would move up and down like that. And I'll go over that in a little bit. So another example is the MD Ridoy video posted on TikTok in 2023. It's showing gravitational lensing, a leading edge vapor cone, and saucer-like skipping motion. So the video, I've compiled it here on the left. It not only moving left and right, but it's also alternating up and down in descension. So this is the video here. What I like about it is a passenger is pointing out the aircraft, and the other passenger, the camera operator, puts his cell phone up and he records this. Now you can see the camera is moving around. It's not stable. And right there, the disc zips off at a high speed. So I've stabilized it and enlarged it. And on the left-hand side, you can see it a bit better now, and it's a nice stable image, and you can see it's moving across. I'm going to zoom forward, and I'm looking specifically for background deformations. Here we go. So you can see down here, the background is deforming as it's moving in front of. there's a bit here that it moves back and forth, and there's a bit here where it's also moving back and forth. And then this is an interesting part. This area here, this background landscape feature, is momentarily blurring as it moves back and moves in front of it. So that's a deformation blur. Now, this is important, and this is where the last bit, the vapor, leading edge vapor cone appears. It's as it departs at a high rate of speed. You can only notice it when it's on a frame-by-frame basis, or when you really, really slow it down. When I first saw that, I realized that is a vapor cone. And that vapor cone looks exactly like the spatial compression that I previously plotted in the color map. So I've blown up the color map, placed a disk of the same shape and size on top of the color map, and you can see there's a 1-to-1 correlation between the theoretical spatial compression and the photograph and the video still image of the vapor cone in front of the UAP. This was filmed 2 years ago. Nothing was ever published about leading edge vapor cones. How did the videographer Ridoy know to fake this? When this was filmed, a lot of people responded, "Oh, it's good CGI. It's great CGI." But like I said, the background is deforming. If you're using something like 3ds Max, the background doesn't deform. You intentionally have to deform it using what's called a helper object. If you're using a video game render, those will accidentally deform background objects. I discovered that in a video online. But in this particular case, this is not a lens flare. You can see the lens flare in 3 spots. There are 2 spots on the left, 3 spots on the right. This is detached from the craft. It's not a lens flare. So how does this work theoretically? Well, if it takes all of its, if the disk takes all of its nested warp nacelles, tilts them horizontally into a cone shape, and turns them on simultaneously, it will create a warp bubble perpendicular to its disk, and it will fly off at a very large rate of speed. So again, if hoaxed, how did MD Ridoy know to fake the leading edge vapor cone? So now we're going to get into some of the work we've been doing with CISA, which is how to detect in the field gravitational lensing. Normally you take a laser pointer and someone would circle it around a UAP in the sky to point out to others. However, when that was done, I found a couple of videos where the laser pointer is actually bending. You can see it here. C, it's bending in one direction, and in D, it's bending in another direction as it's pointed on the other side of the UAP. Contrast enhanced, you can see a little bit clearer, but it's clear. This laser pointer, this laser beam is being momentarily deflected. Now this is an image that CISA took. Again, a laser pointer was on the other side, and in A, the light passing behind was bent down and it shows up around. In B, the light has disappeared from around it, and that light is actually being deflected away from the camera by the Alcubierre warp bubble. So how do you do recommended repeatability field testing? Take at least 2 laser pointers, point them steadily on the other side of a UAP, and let it pass in front and try to detect if the laser is being momentarily deflected. That's one option. The option 2 is take the laser pointer, and you need to have it, the camera operator cannot use it. You need a third person or second person off in the distance, preferably perpendicular, and try and wave that laser pointer through the lower warp bubble underneath the UAP. Don't do it above, because if it's a helicopter, you could blind the pilots, but do it below. If there is a warp bubble there, that laser will momentarily actually not just deform, but actually deflect and change direction. Depending on where it goes through the warp bubble, it'll either bend down or bend up and that will be a definitive result showing that there's deformation happening to the light. Now, there's another example that I'm recommending as well, taking the radar that the Tedescos were doing and add in a passive radar system, but tilt all of the antennas vertically so that you can then recreate a 3D plot of the radar. So what they were seeing plots out X and Y, but if they had this as well, they would actually then be able to identify the elevation that the radar was returning along. Now, flight safety considerations. We need to think about this when it comes to zipping off at a high rate of speed. Remember back when I was describing if the warp drive is on, everything's compressed, and it looks like you're looking up at the sky, but in reality, you're looking down towards or pointing down towards the ground. So if you think you're pointing up and you accelerate off at 3,000 miles per hour, and you would zip off up into the sky. Now, however, what if you're actually pointing the craft slightly downwards and you turn it on and you zip off at 3,000 miles an hour? This is a mistake. Your craft is going to hit the surface of the ground at a very shallow angle. You're going to create a very large debris field, probably a couple hundred feet wide, probably at least 1 to 2 miles long, and you're going to skip off that ground and you're going to fly a few hundred miles or 100 miles or so and land again somewhere off in the distance. This is a plausible, reasonable hypothesis why the Roswell crash happened. If they thought they were pointing up slightly and they accelerated at 3,000 miles per hour and struck the ground, they would leave that debris trail just as was described in the Roswell incident. And that is my presentation. Thank you very much, everyone.
Chad, that is absolutely amazing. Absolutely amazing, man. Let me bring everybody in. And I changed my microphone settings. I'm just letting you guys know if I am over mic'd or under mic'd, please let me know. Sometimes, again, we're on StreamYard. It uses Google Chrome, so the mic levels are a little wonky. But everybody, please put your hands together and give an enormous applause to Mr. Chad Wanless. Chad, thank you so much. Do you guys have any quick questions?
Do you have a presentation or a write-up with just a lot of the photos of UFOs besides simulations and any settings used to do those simulations so that someone could duplicate it? It's very interesting.
Yeah, I've got a lot put in our book, and then I do have an Excel spreadsheet. We are trying to get a new paper to be published. So it's currently being written, and that paper will include the actual Excel spreadsheets as part of the publication. So people will be able to go over it themselves. So
thank you.
Okay.
That's very cool.
And I wanted to put this up for you guys. Chad, this is your book, Hidden in Plain Sight, Evidence of Exotic UFO Propulsion. This is, people can get it as Kindle. I think there may be other formats as well. Again, this is an incredibly well-written book. And so everything that you presented today this is amazing depth of material. You have far more in this book. And to be honest, you probably have enough to write a couple more books. So that's what we've got there for that. But I did want to show that to people.
Chad, if I could get a question here. Your presentation, absolutely phenomenal, sir. The depth that you've gone into with this from all these different angles, I am absolutely blown away. One part of your presentation where I was getting some questions coming in my head was with specifically the buoys, right? How you had the staccatoed return signals versus the buoys. Now it looks in that image as though the buoys did have their own somewhat staccatoed signals returned. but it was obviously much more apparent with the UAPs. My question was, did you manage to go down the path at all to be able to get any additional data for the specs on the equipment that was being used?
All of that is in the Tedesco brothers published paper. I used it because they reached out to us. They had identified gravitational lensing in their own work, and so I wanted to present it in here and combine it in with the Tic Tac incident, and it's recorded as well. But yeah, all of their that information is all in their paper.
The reason I was asking was because of mixing. It could also be, instead of just a countermeasure or instead of a delayed return, it could also be some kind of mixing with the existing RF fields on the surface of the craft.
Yeah, that's possible.
And I'm just surfing through selections from the book. And again, this is available on Kindle or paperback. And I don't strongly recommend books very often, but I would absolutely recommend this. Again, Chad, the work that you're doing, for me, I think this is on the cutting edge of the UAP phenomenon.
Thank you.
Okay, well, so it is 1 p.m. So what I'm going to do is let me take that down. Guys, let's put our hands together and give Mr. Chad Wanless one more applause. Thank you so much, sir.
You're very welcome.
I'm going to take everybody out now, and we are going to go to Jenny Nielsen. I was going to call you Dr. Jenny Nielsen, but you're not quite there yet, right?
Not yet. Not quite yet.
Okay.
All right.
Jenny,
hey. Hello, everyone.
Want to upload, or do you want to do a screen share?
I think I uploaded or did it not upload?
Yes. No, it did. That's my fault. I'm sorry about that. Here, let me put it back.
Okay, good. No, that's all right. I took down. No, and I might screen share. I'll probably screen share at some point during this, but no, this is good. All right.
No, and you are a relative newcomer to APEC. Just to preface this, you did a presentation on, with theories that you're working on, right? And again, you are a postgraduate student, so you are trained. You are in the physics area and in the community, and you have an interest in warp drives and UAP, and you're working with Jack Sarfati and a ton of the physicists in this area. So you are like, I don't want to say the next generation, but you're it, ma'am. So
thank you. Thank you so much. I appreciate it.
Oh, absolutely. Thank you.
I'm really honored and excited to be here. So last time I was here, I gave an introduction to the theory. I know that I have some viewers who missed the last presentation and are still interested in the theory. So I'm going to go through a little bit about the theory at the beginning relatively quickly. So I'm working in a theory that is based on the complex Hopf vibration. So that's spelled HOPF. And that is a mathematical object that represents how higher dimensions project to lower dimensions. So if you've read Madeleine L'Engle's A Wrinkle in Time, or if you've seen Salvador Dali's Tesseract Cross, where he depicts the crucifixion of Jesus as if it's on a higher dimensional object, you could quickly Google these things if you want. I'm not going to interrupt the screen to do it. But so you know that there is this way of projecting a higher dimensional cube as a unfolded set of cubes, and that's the Tesseract cross that Christ is on in the crucifixion picture that Salvador Dali did, and it's also the Tesseract that Madeleine L'Engle talked about in her book A Wrinkle in Time. So you might know what a tesseract is. It's a higher dimensional cube represented as a unfolded set of cubes in 3D. And basically what that tesseract is doing is it's letting you see a higher dimensional object as it projects to our 3D space. But it does that basically like you're seeing a cross section. So if you were a little flatlander and you were walking across the table, if I set a cube on the table, they're not going to see the whole cube. They're just going to see a square. Or if I set a sphere there, they won't see the whole sphere, but they might see a cross section of the sphere. They might see a circle, especially if I'm able to like intersect that sphere with their dimension. Now, if we have a much higher dimensional sphere, the sphere also can be projected down into our dimension. So if you think about a 4D or higher dimensional sphere, meaning extra physical dimensions, not just time, and you project it down to ours, it'll look like this hot vibration thing. So if you see this circle and it looks like sort of an unfolding nested of circles within circles within circles, except they're spheres, but each fiber is a circle. That's what the hot vibration is. So just wanted to give a little bit of an introduction there. Now, going to the next. So in my theory, we're doing quantum gravity, which basically just means that we're depicting gravity and quantum fields as the same thing. So there's no difference. Gravity is just a level of interpretation of the same field. So a single field, in my theory, covers both gravity and quantum mechanics and quantum fields. So it's a theory of everything contender in the sense that it may be able to describe all dynamics of particle motion using this theory. It might be able to explain how quantum mechanics and general relativity can be combined into one theory, and also we can get the particle masses out of this. I've been able to get the leptons, the heavy leptons and bosons. I have a more speculative calculation for the neutrinos that I'm going to work through. And my paper is about to be submitted for review to a topology journal. And in that, I'll show my lepton derivation, at least there, and probably the bosons too. So that's why I call it a theory of everything. You can get a lot out of it. I don't really believe that there's such a thing as a real theory of everything, and as in everything. Like, I don't know if we can really explain, for example, the measurement problem yet. I think I have a better view on it, but I don't think I have that solved. And also, I'm not sure that I think that what I'll be able to do with this thing is describe all or most of known particle dynamics. And also, I have a easier way to get to a time travel system with this. So I thought you guys might like that. So this is the hot vibration. It's a stereographic projection of a higher level to a lower level, higher dimensions to our dimensions. But it's described mathematically just as a set of fibers which are wrapped around a base space. So the base space, if you poke a needle through the base space, you can hit any point on the whole collection of fibers. And in my theory, the fibers are world lines. So each fiber represents like a path of a particle, or a path of a person, or a path of some massive object moving through time and space. So, but the cool thing about the base space is that it's sort of like a shortcut between any 2 points on that whole thing. So you can think of it as sort of the space of EPR, or the space of entanglement. So EPR meaning that Einstein, Podolsky, Rosen, both the bridge and also the particle entanglement. So you can describe both of those things using the base space. I haven't explored that a lot yet, but I will be exploring that in detail in an upcoming paper, possibly this paper, but this paper is getting so huge, I think that I'll probably do that in the next paper. So we have a bundle. It's called S1. Those are just the little fibers. S9, it's a 9D sphere, and it's over CP4, which is just complex projective space. And it's 4-dimensional, but it has 8 parameters in it. And that's how we map between any 2 points in the space. And that's why I say it's navigable, in the sense that you can use the mathematics of the base space to find how to get from any one point to another point. So we unify gravity, the gauge bosons, the fermions, and Higgs. Everything's derived topologically. And also time is relational and it's complex. So in that sense, time is represented as a complex object. You can kind of see a hint of that in the complex projective core of the whole thing. So you can kind of see all of time at once when you're looking at this. You can think of time as every possible event that could ever happen is in this space. So in that sense, you can think of it as both determined and free, because maybe it's possible that we can choose between where we go or whatever. I haven't solved free will, but there's the possibility that we can choose. But every possibility is mapped. So there's that kind of, well, every possibility that could ever happen, we can see it in a sense, but also things might be free because there's a lot of parameters that are left open to at least randomness. And then whether randomness fits to free will, that's a question like Sabina Hosenfelder will say no, I'll maybe say yeah, maybe, so it's a big open question. Then the role of the fiber, it generates topological twists. It also, gravity and time and the cosmological expansion all kind of hinge on the twists of these little fibers. And the fibers are also timelines. So I don't need to get into all this, but you can see it's kind of like there's three metaphysical views of time. There's the evolving universe, there's the eternal universe, there's the idea that now is all there is. But in my theory, all three of these views are just different ways of tugging at the same elephant's tail, I guess. And also I have cyclic time. So I deal with time as something that can loop in a certain way. It's changing as it loops, so it's more like a spiral than a perfect loop. You can kind of see in that illustration there. And also Kurt Gödel's thing there, you can kind of see the spiral. So it's not like a perfect, I don't think of it as a kind of perfect return, but because the torsion of the field keeps shifting time forward, but it will be close. You can do almost a cyclic, you can almost do a closed loop. Okay, there. So now the question is, what's cool about this theory? Well, like I was talking about earlier, there's the core of the field can be used as a way to get from any 2 points to another, from any one point to another point. You can use that center to get from one point to another because it connects everything in complex projective space. So that means, and also there's torsion present in my theory, not just in matter, but in the field too. And it can propagate. So I'm still looking at the effects there. Torsion is very small, so it would be very difficult to detect, maybe almost impossible with current technology, although I'm going to propose some experiments that will help us get closer to that. And there's torsion. There's also the complex space, which maps everything. And wormholes don't require exotic matter in my theory. So that's exciting because that makes wormholes a lot more achievable. And also the energy required to make wormholes is fairly low. It's still kind of expensive to build a wormhole, but I'm going to kind of propose a way to do that later today. Okay, so, but first, so this picture I have here, basically, you can see different versions of the hop vibration. One is, you can see spirals in it. You can see just the individual fibers. It kind of looks like a slinky. So if you remember how in Donnie Darko, they used the colored full slinky, the rainbow slinky, to represent a wormhole. You can kind of think of the whole field in a way as a giant wormhole in my theory, because everything is connected to everything else. But you can look, and then if you remember when you were a little kid and you were at the dentist's office and you were bored and you put these little blocks over those loops, that's kind of like what particle timelines are like in this theory. So they're just kind of moving over the whole thing. And then I have these Russian dolls. And the reason I have the Russian dolls is because there are different levels of the hop vibration. And so you have a 3D level, a 4D level, a 5D level, and it just keeps moving up. You can keep, and I have, because I've written this on the complex hop vibration, you can go from S S3 to S5 to S7 to S9. And those are the levels that are perfectly mappable. So there's a 3D, a 5D, a 7D, and a 9D that are perfectly mappable under this system. And different levels of particle interactions occur at each level in the set of dolls or the set of shells. If you remember the shells from the very beginning, that's what those things are. Okay, so this is a list of the shells. And then also you can do a slice of the whole thing that shows what general relativity looks like on this thing, but I'm not going to get into like the reduction or anything, but basically it's really an infinite set of dolls, and I'm only interested in up to S9 because I can get a GUT, which means a grand unified theory, off of S9, and S9, then from there you can move down and find U1, SU2, and SU3, which are the four forces. So you can locate SU2 is on S3 on that level of the vibration. SU3 is on S5. And then U1 is just the fiber itself. And then once you have all that, you can get up to S9 to get the spin. And then you can get spin 10 and SO10 from there, the special orthogonal set from there. And then from there, you can derive all the stuff you need for the standard model. So there's a lot more physicsy stuff here. I don't think, excuse me, I'm getting over cold. I don't think we need to get into all this, but there's torsion, there's torque, and these things do things. But now I'm interested in talking about experiments. So there are some fairly cheap, not really cheap, but fairly cheap in terms of the span of particle physics and how costly things are, especially compared to the LHC or whatever. This is fairly affordable experiments that we could do to test my theory. So this is an experimental concept overview. So we can use ultrasensitive laser photonics and polarization to test some aspects of the theory. We can leverage Bose-Einstein condensates for spin and phase detection. That's going to be a little bit more costly. You can do interferometry for fringe shifts and Barry phase measurements, and you can do particle collider searches for Kaluza-Klein resonances. Tim, did you have a question?
Yeah, so I just wanted to say, I can tell you're getting over a cold, you're having some trouble with coughing. I've had this happen too.
Yeah.
If you need to take a break and drink some water or something like that, let me know.
Thank you. I really appreciate that. I'm sure I'll be okay, but thank you. I appreciate it.
Okay.
Yeah.
Well, thank you as well.
Yeah. Okay. Thank you. Yeah. So here we go. So this would be an ideal way to test some stuff. So you want to detect circular and linear polarization phase shifts predicted by TOFT. What does this actually mean? Well, light will twist or bend, or the phase of light will change because of gravity and how it impacts things in my theory. So, so if you take a laser and then you accelerate the beam, aspects of the beam are going to change phase because of gravity and torsion. So they're fairly small shifts. They could be, the circular shift is about 10 to the negative 3 radians of change. That's detectable with fairly easy garage equipment. The linear change is to the negative 5 radians, and that will be a little bit harder to get to, but we could keep trying. So if we do a pure laser interferometry version, like the best version, we would shoot the laser beam through a Bose-Einstein condensate to get to measure torsion a little bit more directly, but you don't really need that to do an elementary experiment. So this is the experiment that I think we could do now. If we put our heads together and maybe if we found some university that would host us or whatever, we could do something like this now. So the goal is to detect tiny phase shifts and fringe shifts in laser beams caused by gauge field and torsion effects. We would use a high precision interferometer, like a Michelson or Mach Zehnder or Sagnac interferometer with stable lasers at around 780 nanometers. You could do another wavelength, but that would be a good one. So the predicted torsion and gauge fields in space-time would induce tiny differences in phase. That's what I just said, but we'll say it again. And then how we test it is we send coherent laser beams along 2 or more arms of the interferometer and see how things shift. So the fringes will shift accordingly, which can be detected with high-resolution photodetectors and phase-locking electronics. So we'd have to get into the nitty-gritty of that, but I won't go into it today. So the laser source would be a stabilized diode laser. We would only need a few milliwatts of power. We wouldn't need a lot of power. We'd need a beam splitter. We'd need mirrors and optical mounts, an optical table. We need an accelerometer, and we'd need a controlled actuator for the acceleration. So like you could have a linear shaker table or a piezo stage capable of generating small accelerations. So either of those would work. So you build the interferometer on a stable optical breadboard mounted on the actuator that would control acceleration. You'd attach the accelerometer firmly to that platform. You'd align the interferometer arms vertically or in some direction sensitive to the acceleration, and then you connect photodetectors and data acquisition for high-resolution fringe phase monitoring. So you get the idea. We have an interferometer, we have an accelerometer, we have a laser, and we would accelerate things just a little bit in various levels to see whether the phase of the laser changes. So pretty simple. So you calibrate the interferometer, you record baseline interference fringes with no acceleration, you apply controlled acceleration pulses or oscillations, and you vary the amplitude and frequency. And then you record interferometer fringe phase and accelerometer data, and you repeat over and over again. And then you check whether you get this change that we've been hypothesizing will happen. So the phase shifts will be correlated precisely in timing and amplitude with the acceleration is what we predict. The magnitude of phase shifts, consistent with the predictions for torsion, will be on the order of 10 to the negative 5 to 10 to the negative 3 radians. So the circular will probably be on the order of 10 to the negative 3. That's pretty detectable. The linear, more like on the line of 10 to the negative 5, that would be harder to get to that precision level, at home. For a basic home or university lab setup, we can get to the 10 to the negative 3 pretty easily. We probably need university equipment to get to the 10 to the negative 5. So this is the equipment we'd need. Like this, a lot of this you could probably find collaborating with a professor at a university, because most universities have stuff similar to this or stuff on this level. So we need a stabilized diode laser, a Michelson or Mach Zehnder interferometer. We need high sensitivity photodetectors. We need electronic measurement software and equipment. We need vibration isolation platform. That's probably the most expensive thing on this list. We'd need an environmental enclosure, maybe like just a lab would be fine. A data acquisition system and precision accelerometer. That's probably the second most expensive thing I think on here, except for the laser, but I don't actually think the laser would be quite as expensive as they're guesstimating here on this guesstimate I used. Then there's other similar level experiments we could try. We could try a Bose-Einstein condensate spin precision experiment for torsion effects. So you would you set up a polarized Bose-Einstein condensate. That's just basically a fancy word for quantum coherent particles that are pretty cold. And then you apply accelerations, you monitor the spin. We'd expect, this is pretty easy level to detect, 10 to the negative 2 radian precession, and the phase drift would slow over time. This would be a good experiment. Like if the other one worked, if the first one, like that's cheaper to do, we could do this one and then this one. would like help us refine what we know. This is the one we were just talking about. I don't know how I got another one here, but it's the interferometer fringe shift detection. Then we could go for trying to check for time-dependent oscillatory effects. I've got a little bit more about that later. These are more interferometry experiments we could do. You could also set up a particle collider to look for Kaluza-Klein resonances that should be detected because of my theory. But that would require collaboration with people at CERN or whatever. And so I don't expect we can do that yet. So to do any of these experiments, we need a high stability laser system. It would be nice to have the ultra cold atom apparatus for the Bose-Einstein condensate. We could do high precision polarimeters and photodetectors. We would need vibration isolation platforms, ideally. We need torque measurement devices for some of the more advanced experiments. So that would be like micro cantilevers. And then we'd need collaboration with the LHC. And then we'd need high speed data acquisition and synchronization electronics. Like just we need a good computer, basically. But like most of these things are actually fairly easy to get a hold of, besides the LHC and the Bose-Einstein condensate is a little bit harder to. So like we need the sensitivity taken care of. We need to eliminate environmental noise. We couldn't do it here because I'm hearing tapping in the background. Systematic errors we need to try to eliminate, and we need good data analysis stuff. Okay, this is just the kind of stuff we were just, okay, now this is the more interesting part maybe. We could try to build a wormhole that would transfer a penny across the room, say. So we would leverage the parameter of twist torque called Wonder to tune the entry and exit points. And you could measure that thinking about math on the base space of my system. You manipulate torsion in the complex time dimension, and you can create like a tiny little wormhole. So we'd need a vacuum chamber. We'd need a plasma generator, so like argon gas injected in trace amounts. We need a magnetic field coil, and we need electronics, obviously. So the penny wormhole volume is very tiny, so that would be like a few cubic centimeters. We wouldn't need a lot of gas for that reason. We'd need ionization energy, but really on the level of about like a AAA battery, say, so not very much energy. And we'd have to, hold on, what's the next? So here's the step. So you evacuate the chamber, you inject argon gas, you ionize the gas with pulsed lasers, and that will create like a torsion-enhanced plasma ring, which helps you shape the wormhole throat. You modulate magnetic field dynamics to tune these parameters that will start shifting time. Then you introduce a penny on this thing. It says with an automated robotic arm, you probably wouldn't need that. You just need to like drop the penny in. And then you activate the open state, which just means you just keep going with this. And then you monitor the penny at the entry and exit points that you've tuned to using the mathematical adjustments to this setup based on what you know. And then you record the transition time and any and anything else that you expect to have happen, and like how long it'll take, or it could be instant. But anyway, I know I don't have a lot about tuning in here. The tuning really wouldn't be that involved. It would just involve some calculations. But that would involve like how you adjust the magnetic fields, basically. So you adjust the magnetic fields based on where you want the penny to start and then go. And then if you get it to the right level, you can get the penny anywhere you want it to be. So we could try shooting it across the room. We could try putting it in Texas, or wherever is very far from here. And so it wouldn't really be that involved, shockingly. But it would cost about $250,000 probably to get all this equipment. So like the vacuum chamber would be $50,000. The pulse laser system that seems a little bit heavy for the pulse laser system, but it's guessing 100K, you know, and then that would be the most expensive thing. And then you need optical detectors. I don't think we need a robotic arm, honestly, but that might make it easier. And then miscellaneous supplies. So probably about $250,000. I'm guessing we could get that down to 100 grand using used equipment. And then a lot of it would be findable. You know, you could find it at a university campus or whatever. So wormholes are now achievable for not a lot in comparison to how we usually think about these things, because we don't need exotic matter. You just need magnetic fields and a plasma. So then the other thing is that we might want to think about how the transcausality factors impact regular quantum mechanics experiments. So we could think about ways to test for transcausal interactions in quantum space. Now, this has really been done. So there's this thing called the delayed choice experiment and delayed choice quantum eraser experiment. And those things, like just looking at them from just kind of an Occam's razor perspective, they indicate that what happens at the end of a quantum experiment can impact the beginning. What happens at the beginning of the experiment. And that's weird to think about, but it's really not that different in principle from, say, I tap my drink can here, and then some other drink can that it was connected with, somehow its state changes because I tap this and the electron does something, and then that electron does something because of entanglement. And, you know, there are different ways of looking at entanglement. If you believe in superdeterminism, entanglement was just set up from the beginning of time, and it was all on some kind of tracker that God set up, I guess, so that like everything is just correlated because it is. That's one way of looking at it. I don't think that's really how it works. I think the way it really works is that everything is connected to everything else, which is what my model indicates. So entanglement just is a connection over that connected part of the space. So it's not surprising that an atom here could be entangled with an atom way apart, because everything is connected by this extra dimensional sort of core hookup system in the middle of everything. So there's this invisible set of connectors between any 2 points in space. All points in space are connected mathematically. And that, I think, is a better way of thinking about it than it was somehow set up and it's on a timer and then this happens and then that happens. It's like, there's so much randomness involved that doesn't really make sense to me. Why would... It's kind of like the gambler's fallacy, where you try to predict the next coin flip based on this coin flip, and that doesn't work. We know it doesn't work. So I think that superdeterminism is sort of like the gambler's fallacy. Now, that having been said, yeah, everything could be determined at some level. I don't know. I don't really care, but it could be. But that wouldn't be something we could determine with this theory, most likely. I'm still looking for hidden variables, you know, but I'm not super sure that we could like predict the outcome of every quantum experiment or whatever. But anyway, here, so we can test for modified quantum decoherence dynamics. That means like when quantum systems start to fail, when they start to become higher level systems. Oh, and that's a thing in my theory that you might find interesting. In regular quantum field theory, we think of particles as excitations of the field, and I don't. In my theory, and this is more consistent with quantum mechanics in general, particles are interference patterns in the field, not excitations. Because as you get to more massive objects like us, we don't see a lot of coherent behaviors. We don't see me spreading out like a wave throughout this whole room, tapping every point. You know, we don't see that. We are pretty localized, and that's because we're decohered. So particles are really interference patterns of decoherence on the field. So so the reason that we're more massive and we are solid and we're not flying all around all over the place or interfering through doors is because particles are interference patterns in the field. We are decoherent structures to begin with, basically. Now, there might be a way to cohere yourself, but that's for another day. So you could prepare a well-controlled quantum system where decoherence is typically well measured. So like create a mixed state. It's entangled, but it's also bumping into something more massively structured, and it's starting to decohere. So you can use continuous weak measurement over long time scales to track decoherence. We're going to look for like things to start to become coherent again. And that's something my theory predicts. So, so you might see things become coherent again in an oscillation pattern. Also, we're looking for phase-sensitive violations of temporal assumptions. So you can test for correlations between different times by measuring correlations between different times using different settings of phase. I'm hearing background noise. I couldn't get my closed room today, unfortunately, so I'm subject to background noise. Basically, you do a Leggett-Garg type experiment, but you also check the phases of the systems you're looking at and see if the phases correlate with the so like the quantum, you look at the so if you're looking at a laser beam, it would be like the phase of the beam. So you would check the phase and how the phase is impacted by the rest of the experiment. I haven't thought about that one in a lot of detail yet. But basically, you would be checking the phase as the experiment progresses, and then if you'll check how that modulates or varies depending on correlations in time that you detect via Leggett-Garg. Or there's another one, which is a test of multi-simultaneity by Nicholas Geisen and Suarez's groups. And you could check along the course of that experiment, you would just do that experiment where you're testing for connections across time while the particle is being accelerated versus when it's not. So then you would check for entanglement across the acceleration, because the acceleration puts it into a different time based on general relativity, and then you can still see the connection. But we would be looking for whether the phases change during that experiment and whether the phases are also correlated. Then the last one that I thought about was temporal entanglement witnesses. So basically, we're trying to detect whether there are witness variables in entangled history experiments. And I'm not going to get into that really a lot right now, but it's another thing we could do. This is just another way of looking at. And this is a table of predictions. For that, for the first set of experiments that I proposed. I don't really like how I organized it here, but you can see there are predicted phase changes. There are predicted precession values from torsion in this Bose-Einstein condensate spin experiment. You can see time dependence of shifts in. I need to look up which experiment that was because I didn't label it very well. And then you can look for torsion. You can look for gauge sources. There should be some coupling in accelerated states that we could try to detect. But basically, you can go through this. I'm going to make a better version of this table and put it in my full paper because it's not very well labeled right now, so I'll fix that. This is just a more massive version of the wormhole that I talked about last time, where you could try to put a cat through the wormhole. You could also work, there's room for warp drive, and there's also room for anti-gravity in my theory, but I haven't thought about those situations as much as I have the wormhole. It's 3:39. This is about as much as I had planned to go over. I'd like to hear from you guys and whether you guys have any questions so far. So
Okay. Well, so Jenny, are you all done? Should
I'm
we
all
clap?
done with most of what I wanted to talk about. Yeah, I'm just interested in whether people have questions now.
Okay. Okay. Well, this is heavy duty stuff. So
I know it's a lot.
you lost me way back when, but
Yeah,
you know what?
yeah.
It's awesome. I love it. So let me take the presentation down before anything else. I'm gonna bring the whole crew in here, and oops. Okay, I'm gonna take the slides down. Everybody, give a giant applause to Jenny Nielsen. Jenny, you are going to be an amazing PhD. You're already an amazing physicist. You're going to be an amazing PhD.
Thank you.
So,
yeah.
Oh, and there's chat. Sorry, chat. Playing with StreamYard. So yeah, guys, if you have any questions or discussion or anything like that, we got about 20 minutes, I think, until the top of the hour. Jeremy, go for it, man.
Yeah, I want to go. I'll start it off. Jenny, yeah, you went you went fast on a couple of those slides there, and
I'm sorry.
I was hoping that you have a link to your presentation with the slides available that Tim could post for the audience, so that we could kind of go back and digest those a little bit.
Sure. Yeah, and also I have a more involved theory presentation that I did on April 12th. And so if you're looking for theory stuff, that's there. And then if you're looking for experimental stuff, yeah, it'll be posted, I believe. So did you have a question about it?
A little over my head, but I've sent it to a few people for them to come and check it out and stuff. But yeah, this is good stuff. I like what you said about the wormhole throat, and then I was following you there. I'm like, yeah, I'm ready to get on the company to build one of these things. So
yeah, let's do this.
We have almost everything you mentioned for the wormhole. We just got in a massive laser over here.
Oh my gosh!
Yeah, it's a pulse dye laser.
Whoa! Hey.
Yeah,
Let's try this.
Yeah. So pretty much and the vacuum chamber, we have that as well.
Oh my gosh!
Yeah.
Hey, let's try to do this. Oh my gosh! Let's try to build it. Yeah, I was guessing people probably have some of the equipment.
Yeah, we got a lot of that stuff. Do you know what frequency you'd want to excite the argon at?
We'd have to think about that, and that would be one of the tuning variables. So, and by tuning, I mean it's a way of adjusting how far the penny will go, etc., etc. Excuse me, my coughing. I'm not taking questions in any particular order. If you have a question, raise your hand, and I'll try to start doing it more orderly.
So the
Orestis, did you have
argon,
a question?
Yes, once the others are done.
Yeah. Okay.
Okay. What?
Go ahead.
Excuse me?
Go ahead.
Everything's kind of getting out of control now. What happened? Who was talking? We'll keep going.
I was talking. I was asking
Whoever was
about
talking.
argon. You're going to excite it in like a circle or something? What exactly are we doing with argon and lasers and vacuum chambers? I was kind of confused.
You'll be exciting it in a circle around what you're trying to move. Yeah. So the frequency and the level of pulsing and also the level of magnetic field would all be tuning parameters that you can use to adjust. And based on how you the levels you do it at, it'll change where the penny goes. So I don't have all that worked out in detail yet, but I could present it in detail if you guys need it. So I'm excited that we're as close as we are to having the stuff we need. It's pretty amazing.
Yeah, I mean, things are absolutely coming together. Well, and Jenny, I mean, Mark is spearheading a lot of this, but I mean, yeah.
How big a vacuum chamber are you thinking you'd need?
It wouldn't have to be very big. It's just enough to hold the equipment, you know. So.
No, I don't. That's what I'm asking.
So like
12 by 12 by 12.
The coils.
16 by 16 by 16.
I don't know how big. I'm not sure how big the coils would need to be. They just need to be big enough that we can put the penny in it. So they don't have to be super huge, I don't think. Like you need a certain level of coil. I'm just trying, like it would need to be able to generate a certain amount of field. I'm just thinking about, I don't know how big that would be. I'm not an experimentalist, so I don't really think on those terms much, but you need excuse me, you need a vacuum chamber. You need to be able to put the coils in there, and you need to be able to put the field I'm saying field, I'm saying plasma. So I don't think it would have to be very big. But I need to think about.
I got a plasma a vacuum chamber with coils already around it. This is from the Pockland of Gravity Impulse experiment. So
interesting.
This can become a vacuum chamber, and this coil over here is powered by batteries on the bottom. Like massive batteries.
Okay, it's possible. This might work. I need to do exact calculations, but I think that we're getting close. That's exciting.
Don't count on me for calculations. I'll build the thing.
What you're describing is really a plasma. What you're describing is really a plasma coating chamber. So here's a fully operational one. Where's the lens? Yeah. That's a fully operational one. So it would be a modification of something like this, or what Mark's talking about. So I was asking how big it is. Yeah. But when you get all done making this thing work, you drop the penny and what? It disappears and reappears somewhere else?
It'll disappear and reappear somewhere else if it works, yeah.
Why?
It should.
Why should it?
Why? Because space-time is being bent. Because space-time is being bent by these parameters. And because gravity and electrodynamics are fundamentally connected by the fact that the fiber, like the part of space-time that is running E&M, electromagnetism, the twist in that parameter is causing gravity, at least under my theory. So that means that gravity is really kind of it's at least connected intrinsically to E&M, the way if you think about it. So if we can do some stuff to the...
So you drop the penny and it goes a foot to the left where there's a block of iron, and it materializes inside the block of iron. What happens to the iron that was there?
That's a very interesting question. I don't know if it will, it's possible that the iron might interfere to the point that it can't go there. But if you could imagine all kinds of situations that would look sort of like the Philadelphia experiment, where you don't want to try to put the cat there because it might get a little bit messy. But
to answer Drew's question with the Hutchinson effect, we've actually seen wood embed itself inside metal and without any signs of heat. And that was just using electromagnetic waves. Tim Ventura could talk about that more, but
that's interesting. Okay, can you send me something on that? So my email, I'll just post it here in the chat. I have 2 emails, but I'll give you my personal because it's easier to spell and remember.
Has any of that Hutchinson stuff ever been, validated?
Has it been modeled? Has it been modeled?
It's been validated, but it hasn't been replicated.
Oh, interesting.
So,
for example, has anyone in here tried to do it?
So
has anyone in here tried to do it?
Tim Ventura met him in person. John Hutchinson also went to George Hathaway's lab and replicated the experiment there. And then they used the same equipment and tried to do the exact same thing as John, but were unable to replicate the experiment using the same equipment that John did. So it's kind of an enigma how he does it.
Sounds like a magic trick.
Interesting.
It's you'd have a hard time doing a magic trick in somebody else's lab using their equipment.
That's true.
Well, maybe he's really good.
Okay, and I'm not trying to be mean. I'm just trying to figure out if there's a use for any of this. Let's say you build this thing and it worked, and you drop the penny, and poof, it goes 100 yards to the left or whatever. Then you build a nice big one, and you drop a little spaceship through it, and the little spaceship pops out somewhere randomly, or is there some way to?
It's not random. You can tune it. That's what I mean by being tunable. I can, based on adjusting the magnetic field, adjusting the pulses, adjusting the plasma, adjusting the oscillation. You can pick where you want to go. It's navigable. You can. It's mapped because every point in the universe is on this base space of the vibration. So you can calculate how you need to adjust parameters to get anywhere you want to be.
So this is some kind of a Stargate?
Yeah, and it would be and it's mapped. So depending on how you adjust your parameters, you can decide how far away you want to go. So you could go to Alpha Centauri, or you could go to your basement. Just pick. And
is it instantaneous?
Yeah, pretty much. Yeah, it's instantaneous because it works. It functions on the same level of reality entanglement does. It's just a gate. You just step in, you step out.
So when the bottom of the penny hits the event horizon, it instantly goes to wherever it's going, and the top of the penny hasn't left yet.
Yeah, well, that's an interesting question. I think it would all go. I think that's an interesting question. I think
how would it know when the penny starts and stops? There's air above the penny and there's air below the penny. Would all that go with it?
I think the whole object, now the way we're doing it here, I think we're going to put the penny at the very beginning. So it's just going to be there when we start the experiment, it's just going to be there and then you'll see it disappear. I agree that that's a strange question about which part leaves first. I actually think that the whole thing will go, but
what about the air above the penny? Does it go with it?
Anything within a certain sphere of influence will go.
Well, you're in an atmosphere, so you're generating a hole in the atmosphere? You're just going to suck the atmosphere in with it?
No, you're just going to take the air that was with you, not the whole atmosphere.
I don't know how you'd stop it. That you're punching a hole in space. Why wouldn't everything flow into it?
Well, because it's not really. I understand where you're going. All that will go is what's within that event horizon. Nothing that's outside of that will go, because it would have to pass the event horizon, and it won't, because we've set the event horizon to be a certain.
Okay.
Yeah. Any more questions?
Yes.
Okay. Yes.
I actually wanted to say that this was. I want to do this again. Thank you. Because that was. It was amazing. Absolutely packed full of information. And I have friends from Groupon, from our team, that were watching, and to say that they were surprised would be an understatement. Actually, one of them was reading your paper this morning, and he didn't know you would speak today. Imagine that.
Oh, that's very cool.
I only have a less technical question, because you said something about the pennies dropping in and they can reappear somewhere else, and that can be tunable. Mm-hmm. I would love you to comment on John Mack's approach that those beings, whoever they are, may be coming from a different dimension and they can pierce the veil and come into ours. Could this model be used to explain that behavior?
Yes, I think so. I do think so. I love John Mack, by the way. His books were very, they made me think about everything in a different way. The importance of the subjective and the objective together was very instrumental on me when I was younger. But I'm thinking, it could be used to explain that. I also think that to fully explain what the UFOs are doing, we probably need a more conventional propulsion, maybe not conventional, but just to explain how they zip around in the sky. The warp drive effect, when you see them zoom off, that seems more like a warp drive effect than a wormhole effect. But I think that you might be able to explain all of it using this theory, because I have been starting to look at warp drive and how that would be done with it. So I could talk about that maybe next time in a couple months or so, talk about warp drive with the theory. But I think when you're leaving the Earth's atmosphere and you're going somewhere else, I think that they would use a wormhole, because it's just, it seems like the most effective way to just get something.
Many UFO sightings are of wormholes opening and then the saucers fly in from a wormhole.
Yes.
Oh, I didn't even know that.
I personally know people who've seen that.
Mm-hmm.
Oh, very cool. Okay. I've seen the zipping personally. I've seen the zipping and
there's been multiple shapes of those wormholes, but a lot of times it seems like they're square. Just this square doorway opens in the sky and shit comes out.
Interesting. I'm guessing that the shape will be determined by the UFO, the UAP itself, because I'm guessing that they're generating it using the geometry of their spaceship. It's interesting that they might be square, because you think of them as round usually, but I think
the shape doesn't seem to be associated, because you'll have orbs come out of these rectangles, you'll have saucers come out of these rectangles, you'll have different shapes come out of these things.
Interesting. Yeah, and I think that like the wormhole itself could be made to different geometries. Okay. Any more questions?
So what dictates time and space? Is that a quantum effect?
It's a field. It's just a field. It's a field that's just kind of sitting out there.
So
and that's time.
The way I've thought of it is subatomic particle spin, the way they wobble around dictates time and space. And that's where inertia comes from.
I think time and space, I think of time and space as prior to objects. I think that objects are distortions of the space-time manifold.
Yeah.
So I think that the way things wobble is a way to measure time the
way subatomic particles, before they're actually fully particles, the way they wobble dictates their position in space and time, and then we have actual matter built on top of that.
I hear what you're saying. I think about the time as existing before that, but I think so. Yeah, I'll have to think about what you're saying.
We should get on a call and discuss this in deeper on a deeper level and see whether we can actually make something out of this.
Because I'm really excited that you guys have as much equipment as you do. I never expected the wormhole to be the easiest.
On that laser. I got it off of eBay for $400, and that person who got it for free. He found it in a storage locker.
Oh my gosh, that's hilarious. Yeah, I kind of expected that these things could be done more cheaply than I was estimating, but it's hilarious we have so much already, because I was expecting the laser phase fringe thing to be easiest to do. If the wormhole is the first thing we do, that would be pretty hilarious.
The wormhole kind of makes the UFOs obsolete, because like if you got a wormhole to Alpha Centauri B, like why in the world would you need a craft to get there?
Because, you need a craft because you need to take all your equipment or whatever you want to take with you. And
just
also,
put in a Tesla.
And you would need to survive there.
Why not a Tesla? Well, we might want, the craft shape might be important for warp driving, which I think they also do.
Have you watched any Stargate? Like, you get a little creative there. They have a little push cart. That's all they need.
Yeah. And we got about 3 minutes left, guys, just to let you know.
This has been fun.
But Jenny, it's awesome having you here. Thank you so much. And now that you're here, you have to come back, present more. So you got to come.
I will. I'll bring some warp drive projections next time. Let's give it a couple months, and I'll have some more stuff to talk about. And also, I'll bring more exact tuning instructions for this wormhole, since we're much closer to building one than I thought we would be.
I think it's an interesting idea, right? Like how could you? Sorry about that. Somebody turned on the.
I did.
Please, because we get a lot of garbage comments that come up in the chat. So I try and cherry pick those. So let me see. It's 1:58, but I would say, Jenny, come back, bring experimental stuff, and
Yeah, for sure. I'll bring experimental stuff, and also.
And maybe we could have another conversation offline at some point if we're actually.
Sure. Yeah. I want to do the tuning calculations because I wasn't worried about them because I didn't think we'd be anywhere near building one. But now that we are, oh my gosh, I'll have to start digging into that a little bit more deeply.
We have somebody who can help solder too.
Dead fish cheese spread. Yeah, these comments like this are good because these we can kind of cherry pick, but we get some bad comments in chat, so I don't want to have them all scroll up.
I have a question. I have a question. I'm just curious. Have you looked at like previous experiments? Let's say Gravity Probe B or something that's like pretty subtle, to see if there's anything different. What your theory predicts?
Actually, there was a dark photon experiment recently that rooted something to torsion that looked like it might connect with my work because it was one of the first experiments to actually measure torsion in matter, at least. So that was an interesting thing. not to measure torsion. Obviously, there's torsion all over the place, but the first to measure torsion due to gravity in matter. And so I found that overlaps with my work. Nawal, how we control location would be by adjusting parameters of the experiment in order to adjust where the object goes, and you would tune those parameters according to math on the CP4 base space, the complex projective force space. So that's how you would do it, but I need to actually start working on that, obviously.
Awesome.
Any more?
Yeah.
Okay.
We're at the top of the hour, and Orestis has been patiently waiting to present on UAP implant sample. So, guys, before we go to that, let's put our hands together and give Jenny Nielsen one more giant applause. Jenny, thank you so much. Thank you so much, and you're welcome to come back. Bring more stuff.
Yes, it's great to be here again. We will have more to talk about. All righty, I will take care, everyone.
Okay, thank you again. Okay. Well, Orestis, thank you, sir. Thank you. I'm still taking folks out here. There we go. Okay. And so you are doing a presentation on implant and UAP samples. And this has been, just to kind of preface this for the audience, this has been kind of a growing area of focus and interest, right? Jared Yates has really been pushing this forward, but he did the Earth's part sample analysis, and then Frank Kimbler's Roswell Skip Site, and there was the San Augustine sample from Steve Colburn. And then we keep hearing about all of these other samples. And then you have done work as well. So you have you have a presentation. There we go. Let me add that to stage. And you can use the forward and the back buttons to present on that. And again, thank you so much. Let me hand things over to you.
Thank you, Tim. It's been a while. So yes, the samples out of all, they are the extraordinary evidence for our extraordinary claims. We used to rely on witness testimony. This is very valid. This is the way to go. But if we want to make a strong case, and if we want to better understand how exactly these things work, we need to get our hands on their materials, on their items. So that's what I do. I like to focus on that chapter of ufology because I believe it's the strongest one and the most helpful one for the understanding of this phenomenon. So I made this short presentation because I keep it short and to the point in order to show our audience what our research has been on this topic in the last years and what the next steps might be and how maybe, just maybe, we might be beginning to see a few patterns that can help us understand how they work. So this, of course, requires us to delve into the science a little bit and, using microscope images from the laboratories. There will not be too many of them, but I'll be sure to answer any questions anyone may have after the presentation. So our evidence comes, of course, in the form of the small pieces that were entrusted to us. And I call them little legends because even though they are small, each and every one of them is very valuable and full of potential. And the implications of some of the findings of some of them are absolutely immense. Now, of course, we cannot proceed without naming the absolutely number one, Dr. Roger Lear, who was the first to bring this subject to the attention of the wider public. His groundbreaking research involved rigorous scientific testing of these objects that he himself would surgically remove from the bodies of his patients or people. Now, even though the purpose of those so-called alien implants remained and still remains unknown, he was the first to find some clues that they may have something to do with the human nervous system, as they wrap themselves around nerve fibers and release certain substances that cause even more such fibers to form around them. So they're doing something with our nerves. After his death, his research seems to have faded into the background of ufology, despite it being the most glaring example of direct intervention in human affairs by a foreign intelligence. But the implants did not fade like the research did. They are still occurring. They are still being found, and some of them have found their way into our laboratories. They come in all shapes and sizes, and they're not made of ordinary materials. This is one of them, for example. Many of them are transparent. This one is actually transparent. It's not gray, it's not metallic. It looks like glass, and it takes the color of its surroundings. If you place it near something, near something that is blue, it will become blue, for example. Now, you can notice that it has some colorful things inside of it, and it's not sharp, so it's not glass. It doesn't feel like glass at all, actually. It's hard and heavy for its size. It's tiny, but it's still heavy. You can tell it's heavy for its size. It feels more like a transparent ceramic of sorts. And when you tweak the lighting and the angle just right, you can see that among the other objects, it too has those small hair-like things protruding from its body. And they are not hairs because, for one, it has never been touched by human hands, never. And under the microscope, and this is a very precise microscope, it's a scanning electron microscope used to give us details down to the micro nanoscale. And you can see them better. I pointed them out with the arrows there because it's only in gray. So these fibers appear in several other objects, may not be playing a role in its function. And as you will see in another object that I will show in a few seconds, they have smaller fibers inside the larger ones. So there is some kind of a functioning role there. They may be used for attachment for all we know. Like this one, this other one, this is tiny. Again, those things are very small, but not all of them. But this one felt more like glass because when the witness tried to cut it with scissors, they couldn't. It would not be cut, and the scissor would slide, across the object, and you would hear the sound of metal sliding across glass. So it was hard. It was like when you tap your finger on a glass screen, for example. Definitely something weird, and it would latch on. Those teeth, those claws that it has underneath it, they were actually latched, onto the skin. So, of course, implants being implants, if they are not taken very proper care of, they will soon start breaking down. They will self-destruct. And there are a few ways to go about preserving them, which are very involved, and they're actually different for different kinds of objects. Some of them don't even seem to need a preservation, but others do. And unfortunately, for this case, by the time it arrived and we took it to the laboratory, it was reduced to basically dust. But still, we put that under the microscope, and sure enough, one of the most interesting pictures is this one. Again, you see the fibers protruding from underneath it, and you can also see the surrounding mechanism, of the fiber where it attaches. In another fiber that we zoomed into, you could see even more of these little fibers that I mentioned coming out of it. And when we zoomed in, they disappeared, and that was probably because of the charging, because this instrument uses electrons. It showers your sample with electrons to obtain the image. So if it showers, tiny fibers with electrons, they will repel each other, and they may, be caused to move back a little bit. But since we're talking about fibers and thin, straight samples, why don't we talk about this? This is probably the best implant that we have tested up to date. This one remains stable, but if stable here is relevant because it changed, it broke down, and then it reassembled. I had to see it in order to believe it. I never saw it changing or anything, but I saw it actually moving. Like here, for example. Now, this object is very tough. It is just a single millimeter in diameter. And even though I could not easily bend it, I had to keep trying for 10, 15 minutes in order to bend it ever so slightly in order to fit it into an XRF machine. But I will show you the results in a minute. And despite the fact it has been caught having changed, pose or moved, because you can see the loop. The central loop is changing in diameter, which causes the whole object to appear longer or shorter. And in the bottom left image, you can see that there is a cut there. We managed to finally cut a piece in order to examine the inside. And after we did that, a few days later, I noticed that the loop had moved to the new center. So maybe there is a self-awareness involved in this machine of sorts. Anyway, now that it had finally decided which form it wanted to keep, we could examine it with the same instruments, scanning electron microscope, X-rays, and everything. This image shows one of its ends. This is not the part that we cut. This is one of its ends, either its top or bottom. And around on its outside, you can see that it's actually rough. It looks like a tree trunk or a road. That's how it looks like. But to the naked eye, it looks smooth and even a little glossy at times. So definitely something, macroscopically and microscopically. This one actually looks like the result of a process that we call calcination. This is used when we process a material. We heat the material below its melting point in order to remove some impurities. That's what it's mainly used for. And if you recall, the pictures that I showed you showed it breaking down, and they looked like melting. Actually, this is the impression that I got when I first saw those images, that, it's melting. So maybe we are looking at the after effects, even though that doesn't explain how this thing, reassembled itself. Since I found it in different arrangements, in different poses, I then had to believe the witness testimony because it was equally anomalous with what I observed. Anyway, I took that to a university that I will not name because the staff there was absolutely terrified by this object. They didn't want anything. They didn't want to have anything to do with it or with us. But we managed to fit it inside this XRF machine, and these are the results that we got. Now, it contains several elements, and most of them are nickel and titanium. And when I saw that, I was like, wait, we use that in medicine for medical stents, medical implants, of all things. So if the nickel and the titanium were actually alloyed together, something that this machine cannot tell us, but if it were the case, we would be looking at a material that doubles both as a shape memory alloy, because that's what nitinol does, and also as one that is biocompatible, meaning if you leave it inside the human body, unshielded, you don't need to shield it, and it will not provoke an immune response from it, something that most implants do. They do not cause an immune response. They have no entry scars, no nothing. And yes, sure enough, we took it to the X-ray diffraction laboratory, and it was confirmed that the nickel and the titanium are actually alloyed together. With that out of the way, we took it back to the scanning electron microscope laboratory, and we analyzed its insides. And on the inside, you can see that this implant is shown to the left, and to the right is shown another image from a fragment of a spherical UFO that Steve Colburn tested, again to the right, whereas the implant is to the left. The insides were basically the same, and there were several other similarities between the two objects as well. Like, for example, microvoids. there were tiny holes spread across the inside of the sample, and they were splitting in two further down, by depth. And I only actually noticed that in my sample after I read Steve's analysis of his fragment. I went back to my images, and sure enough, I noticed there were holes. But there is more. In addition to this arachnoidal network, that's what I call it, Steve found in his sample fibrous mats of carbon nanotubes or nanorods, those nanostructures that were coated with a strange substance. Now, many fellow researchers wondered if this arrangement could be used to set up a Byfield-Brown effect, an electrogravitic effect. I looked it up in the literature, not as electrogravitics, but as dielectrics and permittivities, and sure enough, a few examples of coated nanotubes came up. The dielectric constants in them, in coated carbon nanotubes, can be as high as 200,000 or up to 1,000,000 at low frequency. Like, to put it into perspective, this material that uses cobalt and iron can be applied over a graphene platelet, and this will give us a permittivity of about 1,000,000. But when you take the same material and you instead apply it to a multi-walled carbon nanotube, we get an extraordinary high permittivity at the power of 12, which is still relatively high even into the megahertz range. And that satisfies a lot of requirements for the electrogravitic effect. You have a high permittivity, you have a very conductive sample, and if you look at the cross section of a multi-walled carbon nanotube, it actually resembles a capacitor. You have the conductive side and then the dielectric in the middle. So while there is no definite proof that coated carbon nanotubes are a means of propulsion in these objects, the current understanding more than allows for it. If a prototype could be made specifically for this application, specifically for this purpose, then it could easily prove or disprove the electrogravitic effect, because as we all know it requires a high dielectric permittivity in your insulator. With such numbers, you could demonstrate it. You could produce a very strong effect. That's what you would expect. So with all this evidence on these spherical UFOs, I revisited our database and searched for sphere report in Greece. And I managed to find a few of them that are actually very intimately connected with our topic today. And this brings us to the next part, the second part of my presentation, USOs. Now, not all UFO sightings are created equal. That's what I'd like to say, because a sighting in the sky is usually all there is to it. Like, unless you can film it, with good instrumentation, in order to maybe see the gravitational lensing that Shad presented us, or things like that. That's all there is to your sighting, and that's amazing. You saw a UFO, but if you want to really delve into the phenomenon, we need more information. But that's not the case for USOs. No, USO reports, most of them are very useful, very important, because of their interaction with the nearby bodies of water. This can give us a very good insight on how their field works, because there is no dispute that most of these objects come and go with a field around them, and we need to figure out exactly what it is, not whether it exists or not. It does. So this is one case. This is AI generated. You can tell this was in the island of Kefalonia at the west side of Greece. This island is full of such USO reports. And on one occasion, 3 brown spheres were seen falling into the water at very high speed. And they did that without crashing, without causing a lot of turbulence, nothing. They just went straight into the water and disappeared. Or another case, again AI generated. It was dark night, and there were two fishermen on a shore, and they saw as the water started, it was as if it was boiling, it was starting to turn up, and then this big transparent sphere rose from the water, and that was 20 meters from them. That was very close. It was emitting a very high-pitched sound, and it just hovered there for a few seconds, and then it shot straight up into the sky and disappeared. Now, this behavior is actually very well known in ufology, and one of the best sources, to my knowledge at least, is this book right here from Carl Fein called UFOs and Water. He doesn't differentiate. He says UFOs are UFOs, same thing as USOs, and I agree. And their interaction with bodies of water, whether that be water, ice, vapor, or even the ground, even the moist ground, shows us, gives us a lot of information on their field, which he proposes that they have one. Reading that book, I began noticing that if you were to take a Searle effect generator, I don't know if it works, but if you were to make a working Searle effect generator and put it inside a saucer-shaped vehicle, that is exactly what you would observe. The geometry of the magnetic field would interact with the water in the way that it is rotating, exactly the way it needs to do if there was a Searle generator inside it. Now, Patrick Jackson's book, The Sphere Network, also revolves around his theory on what these spheres are and how they operate. In Close Encounters, one category of anomalous observations is that cold spots or dramatic temperature fluctuations are noticed in the presence of those small objects. On a few occasions, and that comes from personal communication with the author, on a few occasions, the entire room or the entire area would suddenly become cold when a sphere would make its appearance. Even on another occasion, like, okay, now we are moving away from the larger UFOs from the book, and we go to the smaller sphere type. The larger UFOs will cause ill effects, adverse health effects on the onlookers very often. And sometimes, even when one of them is landed, there are multiple examples of those. When one of them is landed, if a witness approaches it, it will fly off. So maybe it's a way to prevent the person from getting hurt. So in this report that I gained through personal communication with the witness, a small sphere, very small sphere, appeared to be scanning his room, and it approached him. Being curious, he reached out and touched the luminous orb. And when he did, his finger started feeling tingly, and it kept feeling so for a few minutes afterwards. This is important because that shows that if the witness did not experience any health effects in the presence of a functioning UFO, a high-powered one, to appear luminous, then either those smaller objects run on lower power, or they use a different form of energy, one that is safer when they are around humans. And that means they may be made to be around humans. I mean, there is a good example from a friend that I have. He used to be driving out in the desert, and he saw two of those large saucer-shaped objects come out of the mountain range, and that's the last thing he remembers. Next thing he knows, he wakes up in the hospital with severe burns. And he went back to the site. The road there was burned up. It was black. So this was probably an accident, because there is no reason why they would need to attack him. But that just shows you the dangers of approaching one of those objects when you don't know how they work. We need to figure out how they work in order to be better prepared to help these people that may be affected. But I digress. back on topic on the small spherical objects, this is another curious report that I took from my friend Ion Panidis from Groupon. In this case, the witness was in her living room one day when she saw this transparent sphere enter through the open window. It flew past her without making any sound or causing any health effects, and it proceeded to scan the bedroom, the kitchen, the bedrooms again, and then retraced the entry route and exited the apartment before shooting up at a very high speed to join a blue light that was apparently waiting for it high up in the sky. Talk about portals. The witness was calm, kept calm, and managed to take this amazing photograph. It shows a small transparent sphere that may be a cloaked one with two smaller ones inside it. And they are luminous, meaning they are operational. Their field is on. And that reminds us of the famous Bet sphere. This same old story. Allegedly, it was X-rayed, and it was found that there were two smaller spheres inside it. Same thing. And the Bet sphere in itself reminds us. For some reason, I cannot show this slide, but Ross Coulthard did a documentary recently where he visited Jim Marlin in Texas, who happens to have a sphere that looks almost the exact same as the Bet sphere. And in his case, in Jim Marlin's sphere, this object came from a UFO. Allegedly, a craft flew and it released these multiples of those spheres, and it was picked up by one of his friends, and then he gave it to him. Whereas in the other case, with the transparent sphere, it went to a UFO. So the theory that they are probes or drones, sounds plausible in light of these examples. We have other reports, many reports from Greece involving these spheres. This one, for example, is over the Taigetos mountain range, which is close to Sparta. Specifically, that is over a location known as the Pyramid of Taigetos because of the conical mountaintop. It looks like a pyramid. Another example here, same configuration. Notice 3+1. Again, 3+1. This one is from Mount Olympus. And Mount Olympus is actually a hotspot of UFOs. Mount Olympus, I don't know if it has any connection to the myths or not, but data is data. There are so many reports in that area from Mount Olympus all the way up to Thessaloniki, the nearby city. There are dozens of UFOs seen there at each time. One report even shows some 20 or 30 of those small objects. There are a lot of them. And don't even get me started about Athens. The reports of spherical UFOs there abound. There are so many of them. So the point is that even if the spheres run on this relatively simple principle of electrogravity, reports of them go so much back in time that a human origin can effectively be ruled out. The spherical design would help to make the electric field asymmetrical, which is actually required for the Byfield-Brown effect if you read Townsend Brown's papers. And coated carbon nanotubes boast very high dielectric permittivities. So if distinct groups of coated carbon nanotubes were to be spread across a spherical vehicle, they could make it omnidirectional. It could activate discrete, separate cells in order to quickly move around and change directions. And you would need that if you were to make a small probe or drone for the purpose of moving around buildings or populated areas, which is the behavior that we are observing into the spheres. Our research, again, has to be evidence-based. And I would like to quote Dr. Lear again, that the only way to unlock the secrets of this phenomenon is to follow the science. Now, you have to wonder if the spheres, if those small UFOs are released into populated areas because the larger ones are dangerous, then we are seeing an approach, a purpose that this NHI may have that looks to preserve the human race. It doesn't want to harm us. Whether this preservation happens out of charity or out of interest remains to be seen. But so far, it seems we may have just started looking into patterns that paint the image of a new candidate for man's best friend. Thank you all for watching, and I'll be very happy to answer your questions.
Orestis, thank you so much. Thank you so much, man. Okay, put my earphones back in here. Rock and roll time. So I'm going to bring everybody in again, as is our tradition, richly deserved tradition. So let me take that down for a bit. And I think I've got pretty much everybody there. Let's give an enormous applause to Orestis Lazanakis. Orestis, thank you. And I owe giant thanks to Mr. Jared Yates also. Jared is the one who made contact with you. You guys have been talking about implants and samples and UAP for like a couple of months now. And Jared actually approached me. He said, you got to have this guy on. He's doing the work, right? So
thank you. Of course.
I'll bring Curtis on there too. Okay. So yeah, I mean, we can do, if you guys want to do Q&A or half an hour of discussion back and forth with Orestis on the samples, that's cool. That's our lineup for today. We had one more fellow in our queue, but he had to push back, and that's cool. It happens sometimes. So yeah, after this we'll go to lab time. But you guys, you know what? I will start with a question. Orestis, what are samples that you're aware of other than just the ones that you're working with? Because you're working with biological stuff, and then there's crash wreckage also. Are you aware of others that are floating around? Like Roni Vernet has, I believe, one that he's talked about that's being analyzed in Brazil. Any others come to mind?
They do. Plenty of them, actually. I'm actually expecting 2 more samples to arrive any day now. One of them is from an older crash in the 80s, and another is from a TR3B, like from a black triangle. Finally, we will have a piece from that category of objects. Let's see if they are government secret technologies or not.
Well, we've been able, and when I say we, I mean like Jared and Michael Perrone and Mark Sokol, right? Not me. I just take photos of them doing it. But they've been doing SEM and TEM analysis of these samples. Dr. Matthew Sadagas did neutron activation analysis of these samples. And so we're starting to create kind of a library of material, right? And I mean, I would love it if you feel comfortable, if you're able to contribute to that and work with these guys. The more that we're able to get, I think the more that we're all able to learn.
On that note, Tim, now is a great time to plug UFORev.com.
Should I plug the website?
Yeah. So Orestis, I would love to see if we can include some of your public data and links to your stuff on this website. It's a one-stop shop that Tim has put together for all things samples related.
Yeah. Okay. Well, let me put that up on the screen. And again, it's a little, StreamYard is a little wonky, so I have to separate windows. So this is UFORev.com, the UFO reverse engineering website. This is associated with the Alt Propulsion Conference. As you can see, let me see. Here's one from Chad Wanless, but I have Chad's interview up here too, and I'm going to try and put his presentation up as well. This is, I don't know what you would call this website. Basically, the inspiration for this came out of all of the data that's being collected by numerous people, and so I was just like, okay, you know what? I got to start putting stuff up. Most of what is on this website is stuff that was generated by the conference and my interviews and things like that. And that's just because it was a place to start. I would say the thing that makes this for me more valuable is I'm going to slide in here and show you. So right now, everything on this site are UAP videos, right, on YouTube. So I have a tool called exemplary.ai where you plug in the video, and it will go through and create an analysis and breakdown of everything that's discussed. And you could see in this one, this was a presentation I did, I think at the last APEC. It went through and it broke this down into 14 bullet points. I didn't have to write anything. And the thing that makes that really cool is we can do that for every single thing that's here. And so like Mark and I filmed this. This was a lab walkthrough that Mark did last year. All of this is AI generated. It's all searchable. It's all there, and it's broken out, right? So it's not locked up in video. So again, I'm going to put Chad's new presentation and Orestis presentation up on the UFO Rev website. I'll drop a link into the chat. And this is kind of a work in progress. I think I've got about 70 different videos, everything from detection to samples analysis to propulsion. I also have a lot of stuff that Jared collected. He sent me over a playlist. And so there's some Linda Moulton Howe stuff and just other sample stuff that dates back a ways.
That would be great, because end of the day, that's what I want as well. I just want the data and the truth out in the hands of the people whose lives have been stigmatized by being an experience for the things that they have witnessed. You're doing the work. Yep.
Well, I mean, for me, this is just like, I don't know how to express this, but like in our community, a lot of folks, especially in the UAP community, a lot of folks are like, I'm going to stake my name and make a reputation based on this, that, or the other thing. And then it becomes like ego driven or profit driven. And there's not a lot of money in this area, right? I mean, there are a million other specializations you could do in life if you wanted to make money. UFOs are not one of them. So for stuff like the Alt Propulsion Conference and the UFO Reverse Engineering website, it's just like, you know what? I want to try and put egos aside and just get the information out there so that people can use it. And fingers crossed, you know?
Yep. So I have a couple of questions. Two separate ones. The first question would be, for those who are experiencers who know they have an object that's not natural and a possible implant, how would they go about getting it removed? And it's going to be different in different countries. Like in Canada, we have a public healthcare system, so trying to get something identified here and removed is really tough unless it's metallic or reacts to magnetism. Then the doctor will look at it and go, well, that's obviously foreign, we'll get rid of it. But if it's not magnetic, they'll come up with some excuse to not deal with it because it could be anything in there. It has to be clearly foreign for them to actually want to do it. Where in the United States, you can just go down and pay someone to do it real easily. And then the other question was, with the samples you've got, whether they be from UAP or the implants, is there any possible evidence of 3D printing as a form of manufacturing?
Yes. And this is actually a wonderful question. Some of them do seem to be made in a way that we can interpret as being 3D printing. Like it could be epitaxy, it could be some other, even more esoteric technology, or it could be 3D printing. Yes, you could actually see the layers. They were very fine down to the micro scale, but they were there. Absolutely.
Yeah, because the Experiencer Research, I was with MUFON's Experiencer Resource team for a while, and the research shows that it's very possible the interiors of the craft are 3D printed. There's it's just the way everything is made. It reminds me of the 3D printing that I've been exposed to in my engineering profession. And so I couldn't help but wonder if that was something that was showing up in samples.
It sure does. And yes, a lot of witnesses actually are telling us that the inside, the interior of these craft are one piece. Like there is no seam, there is no separation, nothing. They're all the same, and they're butter smooth.
Yep, that's part of it.
Likely.
That's part of it. Where floors meet walls, there's a parabolic curve as well, and that's something you would do in 3D print. If you went and did a 90-degree corner like this, it'd be very weak. But with a curve is very strong, and that's why cars with their curves in their bodies have strength. They don't need extra structural members underneath because the curve itself, the compounding curve, creates strength.
I've even heard about the so-called Roswell foil, that if you actually bend it a certain way, it will shatter like glass. So yes, again, and that happens. That is especially true for the edges. So it is very likely that the edge, which is rough and jagged, is weaker and more vulnerable. Yeah.
I had a couple of questions. Hi, everybody.
Hi.
Hi. I was trying to pay attention, but my internet kept going out there on my end. So forgive me if you already covered this, but crossover with the arts parts research, I was wondering if any of these materials exhibited odd or especially strong dielectric properties and or ferromagnetic properties, possible like layering between those two or variability of those two. Also, radio absorptiveness, like, and what's the other one? Any signs of quantum vacuum field flux changes or asymmetries from these?
Yes, so basically weird anomalous behavior that you would normally not expect from ordinary materials. Absolutely. I mean, the wire is one example. It is this relatively huge implant, 3 centimeters long, and it was caught in different poses. So it was moving. And another one, oh man, I mean, you would have to see in order to believe. I have a small sample. Tiny sample. It's actually like a breadcrumb that big. When I approached a magnet to move it around from outside of its zip bag to manipulate it, it would be very weakly magnetic, very weakly attracted. It was a strong magnet. But when other similar shards of the same material that were metallic were attracted by the magnet, after a certain amount, they were all gathered on one of its side, and then it shot straight up and then straight down. And it was not a free fall. It actually launched up and then fell down forcefully. I couldn't explain this. I just left it alone after it happened because I didn't want to touch it. I didn't want to overload or burn anything with my intervention. And even though it was left alone, it split in two. A few seconds later, it just split in two with a line, with a cut that was almost laser sharp. So yeah, that was, talk about anomalous behavior.
Did you get any kind of record of that?
No,
behavior?
Because I didn't. Yeah, exactly. I didn't know it would occur, so I didn't bring any cameras there. But I was sure to take that into the laboratory. And, a few interesting things came up. It was actually very porous. It was full of tiny little holes, and they had a lot of calcium on their edge or on the inside, but not on the outside. Yeah, definitely something functional, either circuitry or something like that. Yeah, there's just no depth, to this research.
Orestis, there was something that I observed in one of your slides on that nitinol wire that you had where you'd cut it. And this might be pareidolia, right? I might just be seeing stuff that's not actually there. But whenever I look at the microscopic data, the very, very small SEM data, and I see things that have 90-degree angles, like 3 or more 90-degree angles, right? That's when I start getting excited because I'm like, that could be natural, but that's also things that we tend to do when we're making stuff. And I thought that I saw in the center of the cutout part of your image, it looked as though there was a square with a line coming off of it that would have been fairly small in the double-digit micron range.
Yes, good. You noticed that one. That particular line right there it can actually be found all across the sample. I call them cylindrical grooves. Steve Colburn also saw that in his sample. So there's another similarity, one of the similarities that I was talking about. And yes, the fact that the surface of the inside of the face of the cross section was cut, was broken, and you could see the groove behind it, means that it is not the result of the cutting instrument, but it is rather, a component, and that it should be there. It was designed to be there. Yes.
So going back to the 3D printing stuff that Chad was asking about, it seems as though there may be some of these nanostructures or microstructures that are inside these materials, that there's no way that you could have made those inside the materials unless you were building it up layer by layer.
Possibly, in order to find something like that in our samples, you would need to do the much more expensive tests like atom probe tomography or things like that in order to look down to the atom scale, because a TEM needs you to straighten, to flatten your sample. And if you flatten your sample, great, you can observe the atoms, but you will also lose a lot of its detail. So there is this obstacle that you need to overcome.
I think there's also a piece of equipment that's used in biology. It's like a CT scan, but for bacteria. So it's like a microscope CT scan. So you can look at 3D structures inside your material without having to cut it open or anything.
Okay, I was not aware of that. I knew that there is an X-ray test, for microporosity, but I didn't know that there was one for bacteria. That's very interesting, actually, because now that you're mentioning biological material, the wire is one example of them. It actually ejected some biological matter from inside of it, and you can see it. I also took it to the laboratory, but the results were inconclusive. But yeah, sure, there may be something to look there.
If we could get some kind of very small scale CT scan of a implant before it's removed to try to identify how those hairs are connected to the neurons, that interface of that connection might provide a lot of value, not just for how these things work, but things we might be able to contribute to our own science.
Exactly. Like generally, if you could find someone who has, who can be verified to have an implant, then the tests before removal would actually be maybe even more interesting than the ones after removal, because then you can find it's whatever frequency it is emitting. Some of them do, or if it doesn't, you can look whether it is a cloaked frequency or not, because you can actually cloak magnetic fields. This is actually a thing I've read papers in the literature. Yeah. Wonderful stuff that you can do. Absolutely. And in the case of that particular wire, because either you or someone else made that question before, like the absorption of that metal. I took it for an XRD, X-ray diffraction test, that can tell us whether your carbon, for example, whether the carbon in your sample is graphite or diamond. It can tell the difference. They are both just carbon, but that machine can tell the difference. And that's how we found that the nickel and the titanium are actually alloyed. After that test, it stopped moving. Like, I haven't ever seen it having changed after that test. I don't know if it's coincidence or if it ran out of battery, if you will. But there's that. And also the color changed. The black was now less black, if that makes sense. Like in the first pictures, in the first images, it was a deeper black. But after the XRD test, now the black on the parts that were tested looks a bit more dull, like a duller black. Definitely something happened to it there. I'm worrying actually about it.
It might be a worthwhile test to take all the samples you can get your hands on, put them in a very small confined space together with some different kinds of probes, and look to see, are they trying to communicate? Or do they have little nano Bluetooth?
Yeah, you could do that, but remember that most of them, you're looking at the corpses of most of them. It is after they gone through the process of self-destruction. So if there was some circuitry in them that allowed them to communicate, the intelligence that put them in there would not want you to have them. So they would actually have probably burned themselves out. Again, like you said, J-Rod, we need someone. We need to find someone who has an implant. We can verify it, and then right after removal, we take care of it. So as to not self-destruct, we take it to the laboratory immediately. That's the next step into our implant research. Yeah.
Have you thought about maybe putting them in a vacuum while they're under transport or something like that? Because, or at least just not exposing them to the air, because it sounds like they're oxidizing somewhat. Like if you're taking it, they're designed to run inside of a body. They're suddenly exposed to the atmosphere. Then it makes it like they would lose some intrinsic properties.
Yes, that is correct. Now, normally it seems that you don't really need a vacuum. Like, natural solution will do just fine for some samples. Dr. Lear found that if you put them into the patient's blood, they will reassemble. He once had one implant that broke into 3 parts. He threw it into a vial with the blood of his patient, and it fused back up. It reassembled. So yes, a vacuum is one way, but then you risk destroying or harming something because of the pressures in there. But definitely, yeah, there are many ways to go about preserving an implant, and they are not as much.
Just seal involved. It like you could put some sort of epoxy over it or something.
Yes. If it's about oxidation, then yeah, you need to find a way to get it away from the environment. Once there was this lady that had an implant, and she actually found it ejected itself. I don't know how, but it ejected itself. Maybe she scratched her nose or something. It came from her nose, and at first it was like the first one that I showed. It was clear colored, not colored. It was transparent, and it would also take on the color of the surrounding materials. She actually has shown me some pictures of that, and then it started breaking down. It stopped being clear. It became translucent, and then after a while it just evaporated, or I'm just trying to conceptualize it, but it just disappeared. So cases like these exist. They're very unfortunate because you have it in your own 2 hands, and then you're losing it. Yeah, it's so sad. Yep. Anyone?
Could call them damselflies.
Yeah, little legends. They are legends, even though they're small, little. Yeah, and one time I remember there was this case. I had not met that researcher yet, but he told me about this case about another lady here in Athens that had an object. It was removed. It was taken for a biopsy. Was never returned. We never saw it again. That was again unfortunate. There are so many obstacles involved. Then how you go about removing one, Chad? I just remembered you asked. That is difficult because there is this principle in place that says if it ain't broke, don't fix it. So one can say that, okay, even if it's a foreign object, if it doesn't bother you, why remove it? But yes, in some cases they are causing trouble to the patients that have them. In some cases they are actually hurtful. They, I don't know if that's a mistake on the part of the intelligence there or not, but sometimes they can pose a health risk. And I'm of the opinion that if they do, if they're actually harmful for the patient, then they should go to a hospital, refer to another doctor, and ask to be examined. And then they will likely suggest that it should be surgically removed. Yeah.
Now,
I do have a question here. I was just doing a quick lookup here. You said there was evidence of carbon nanotubes found inside the samples, and so I did a quick chat GDP request asking it, what have humans been using carbon nanotubes for? Could they be used for creating circuitry? And it said yes, we have been since 2019 using carbon nanotubes for circuitry microprocessing. Companies and universities include MIT, Stanford University, IBM, South Korea's CAST, and Skywater Technologies. Flexible CNT electronics would be Samsung, LG, University of Tokyo, University of Wisconsin-Madison, and IBM. And just to name a few. So, how far back does the nanotube technology or the nanotubes identification in the research been recorded? Like 10 years ago, 15 years ago, when Dr. Lear started doing it? Because if we can show this existed before humans started using it, that's means something.
It does. Thank you for this next wonderful question. Now, I will not be able to prove this yet, but I know of a story. So, see, Steve found these carbon nanotubes inside the sphere that he tested. So that means that those spheres have them. And I happen to know of a story from Greece here. They actually found, it was a treasure hunter. He found a marble box buried inside a cave, and inside that marble box was one of those spheres. Believe it or not, it was a small one. It had all the behavior of the bed sphere. It was moving. It was causing electromagnetic interference. The owners were getting sick. They were actually hospitalized, and they were afraid of it, so they threw it in a river. But anyway, that shows us that these things are ancient. They've been here for quite a while, and if they have the same technology, and like you said, we can prove it, we can show it side by side, then all hell breaks loose, right? Because you can demonstrate that this technology has been in place for centuries, if you will, if not more.
If I can add something to that, Orestis. So Steve, with his carbon nanotubes observations, he also was under the impression that these things could be used for sensing, like biological compound sensing, right? So if you got this thing somewhere near, like anything that's detecting chemicals in your blood or hormones in your blood or anything like that, it could detect those things. But additionally, CNTs can be used for delivery. So each of these little carbon nanotubes could actually be like, nano-sized syringes. They could contain tiny, tiny little things inside there that are supposed to be released at certain times under certain conditions.
Which is one explanation for the fibers that we see in the implant samples. Yes, absolutely. They are actually made of carbon. We did an EDS on them, and a targeted elemental analysis from the scanning electron microscope, and it came back and they were almost pure carbon. Some of them had some impurities or other elements in them, mostly aluminum, and that's actually interesting. A sample, remember the biological material that I mentioned earlier that came out of that wire, it had aluminum in it, and the rest of it was mostly carbon, for whatever it's worth. That's another finding. Yeah. Basically, carbon nanotubes are like very tiny wires. They are conductive. They can be used to transfer information. So they can double, both as, and they can also strengthen your sample. See, that's a difference between the implant and the sphere. But even though it is a difference, you see another similarity behind the difference, because you take your object and you substitute something for something else, and now you have a different role. So with a simple tweak in your materials, you take the same technology and repurpose it for a different role, for a different mission. One is to, for the implant, for example, is to have it sneak past the delicate structures of the human body. But if you change the nickel, for example, and substitute it with vanadium, now you have beta phase titanium, which is super strong. And if you add carbon nanotubes, now you have an aerospace grade material. And that's exactly what the sphere has. It has titanium with nickel, but mostly with vanadium. So there's that. Yeah. Those two objects prove a lot. Like, so far, we only had witness testimony telling us that it's the same creatures behind the UFOs and the implants. And that's it. But now we can prove it. Now we can prove what we always knew. And what happens if we prove it? We validate witness testimony. We validate these people that have been stigmatized, that have been cornered and pushed out because of what they experienced. That's the fruit and purpose of this research.
So with the hair structures you identified, were you able to identify the chemical makeup of those micro hairs themselves?
Yeah, mostly carbon. Mostly carbon. Could be nanotubes, microtubes. They were at the micro scale. I don't know, but yeah, mostly carbon. In order to do something, in order to find out more about about the chemical bonds, you would need to do a micro Raman testing, or micro XRD, which is XRD but on a smaller scale. Yeah, that's definitely in my to-do list.
Yeah, because I was looking, and there is. We've been using carbon nanotubes for medicinal things like glucose monitoring and stuff like that. So we're already using it for that. Somebody else had beat us to it.
Yeah. Well, and guys, we're at the top of the hour, so maybe we should wind things down for Orestis implants and transition over to lab updates. But guys, I want to say thank you. Orestis, absolutely. Thank you, sir. We've had some amazing presentations today. Chad's was just stellar. Jenny just drilled down on the physics, and then you are taking the implant stuff to the next level. So let's do this before we go any further. Let's put our hands together one more time for Mr. Orestis Lazanakis. Sir, thank you again. Thank you again. And as you have more implant updates and stuff like that, come back, share them with us. So
will do. There is much more to come.
Okay. Awesome. Okay. Well, so we're going to go to lab updates. Who wants to go first? We have Curtis with us, and Drew is around here somewhere. Drew was around here. Looks like Drew dropped off. I'll text Drew and see.
Yeah, I have a presentation there. I can give a short update.
Okay, awesome. Take it away, sir. And I just texted Drew, so I will spotlight. Oh, Drew's back. Okay, so yeah, after Curtis, after you go, I will do Drew, and there is yours, sir.
All right. Okay, so it's been a while, but
oops, so my fault. Sorry about that. Okay. I'm just trying to do you. There. Oh, okay, and I get it. Okay.
All right. So from last time, we have stacks of 1 millimeter disc. So there's 16 or 15, I think 16 1 millimeter discs instead of 8. So part of the thing that we have been wanting to test for a long time is having more discs in the stack. And what that does is that in the theory, the force is proportional, or the the transient mass proportional to the change in change in energy density over time. And so with more disks, we're getting higher values for that. So that's something that we actually have. We're in the cusp of testing. In addition, the linear experiment is still in the works. So I'll get to that. But here's some pictures of the 16 disk stack. As part of this, because we're changing, these PZT stacks, the capacitance is different than the 8 stack. And because of that, we have to use a different winding. So the step-up transformer we were using wasn't tuned for this capacitance. And so there's a new transformer was made, and that has actually finally been put in. And so here's a picture, a side picture of inside the vacuum chamber with the device in the torsion balance and an overhead picture. And of course, this is the Michel's linear experiment. We're still working on doing that at the Fullerton lab. And we're going to be using, one of the things we're going to do besides the aeroslide is we're going to use these magnetic rails to try to put it in vacuum. And these devices are about 1 kilogram. Just to give you an idea, the torsion arm itself is over 800 grams. So it's about the same order of magnitude that we would have to be able to push. And here, so this is a picture of one of the what Jim calls the big ears, and we're still kind of hashing out how to do the supports. That's ongoing as well. Now, here's some recent runs. Now, this was a sweep down from 43 kilohertz to 25 kilohertz. And the thing you want to note here is what happens between like 2 and 7 seconds. Basically, around 3 seconds, you notice that the device is moving, and it's not a stick slip motion. So the device which is the green trace, and the red trace is the torsion arm. The blue here is the basically center of mass calculated value. And you'll notice that what happens is after 2 seconds, you get kind of a push in one direction. So that is something that Jim took note of. And what he did is he actually, instead of doing a down sweep, he did an up sweep. And so what you would expect is around the same frequency, this is around 41 kilohertz, that you would get a similar type of event. And in addition, in theory, the up sweeps are better because the resonance transient is moving upwards in frequency as the device heats up. So you can see here at around 12 seconds, kind of straddling 12 seconds, you notice a pretty big effect where it doesn't look like there's much stick slip happening. The device is moving, and you see the red trace, the balance itself is moving. You get kind of the center of mass, kind of a straight line, just being moved. So that's a pretty promising result. And this is at a different frequency we were working at before, which was around 31 kilohertz. So you see things happening around that. That's around the mechanical frequency, resonant frequency. But here you see something just off the frequency. It might be some kind of electrical resonance that's actually giving us the effect. So that's the main result here. And so we have some videos. I don't know if, the videos aren't able to play, but what I think I played this back in April. This is a video from March 27th. This is in Michel's lab. What you can see here is you can see on the right is another tracker trace. And you can see that this is a linear experiment, so there's no torsion balance involved. There is a small line where the power is bringing it in. The power is being brought in with the pair of wires, and that pair of wires acts as kind of a weak spring. So you'll notice here that there's a pretty large, there's a little bit of oscillation happening as the device is kind of balanced on the linear air bearing. And once the resonance hits, you can see that the device and the system itself kind of move together. And so you'll see this overall kick that happens, and then it goes through a time where it's basically kind of moving like a spring motion, where you see them moving together, and then the device is turned on again. So this was a run where Michelle was turning on the power, turning off the power, turning on the power. And you can see that when the power was turned on, there were times where as it went through resonance, it got a big kick, right? And you can see that kick preferentially is pushing the device in the down direction if you look at the graph. So that's what we see. And as it passes through resonance, we see it switch the other way. So that's kind of what we see here, especially between 70 and 80 seconds here. You notice that it's pushed like pretty much in a straight line. The green is leading. So that means the device is pushing, the rest of the system is following it, and then it pushes the other way. So it goes through a resonance where, if you recall in the theory, you can have a push in either direction depending on where you are in resonance. And we're seeing that clearly here. And that's pretty much it for the lab update. I don't think I have anything else new to share.
Curtis, thank you, man. Thank you. That is awesome. Again, to remind everybody, you and Jim you guys are doing the work, right? That's kind of becoming my theme for this year. And you keep doing it in the background. That's important. It doesn't just stop, right? When the conference is over, you guys are there doing this.
Yep.
So,
and I guess I should say that I am still working on the theory side. So I'm working on a paper, trying to get it out this summer. And I don't want to get too much in detail. There's so much going on with it, but it's very promising. I'm getting good results. I'm able to calculate charge, mass of fundamental particles and things that you wouldn't expect. So it's really good, but I'm not gonna talk about details or anything like that yet. So
awesome. Well, Curtis, thank you. I'm going to take you out, and I will bring Drew in. Drew Arigma from Florida.
Sorry, Gene.
Sir,
and,
do you have a lab update you want to do for us?
Can somebody else do it for like 5 minutes?
Yeah. So I'll tell you what.
5 minutes, man.
Let me see. I'll bring everybody who has the camera on in right now. Anybody else? Anybody have a lab update? Mr. Sokol, Mr. Yates, the usual suspects. Mr. Sokol has one.
Yeah, I've a couple things to update, but we're doing some loud work right now, so maybe Drew can go first.
Drew is he was asking for a few minutes, so.
Okay, so I'll just do it. You'll have to deal with the loud noise then. So what we have to update is we finally figured out what was wrong with our water chiller. It turns out Xinjiang Wang in China put too much refrigerant in it, which was causing the compressor not to work properly. So we ended up removing some coolant, some refrigerant, 410, and now it's working great. So that's chilling our water down to a nice 8 degrees centigrade, which is like creating condensation on the magnet. We installed and removed all of the leaks from our second chiller. This chiller line is connected to this little black box over here, but the liquid inside of it is not water. We're using transformer oil. And the reason for that is because these lines are going up to the chamber. The chamber is floating. So we'll be able to put the entire chamber at potential, and that changes the way the dynamic nuclear polarization and the EPR spectra work. So we have another variable that we can add to the system. Also, the reason why we had to cool down the chamber is because there's shimming coils on top and on bottom, and we have them hooked up to an audio amplifier over here. And the reason for that is it allows us with each microwave pulse to sweep through a short range of magnetic field right around resonance, and we're able to saturate all the different spin points. So there's several different points where you can reach. So rather than being at one spot, we could be at all of them, and then allow the magic to happen during the spin down. So that's actually when DNP happens. It's when everything is relaxing. So that's what we learned from the from going to the UAP hackathon actually was somebody brought to our attention that hey, there's quadrupoles, there's many different ways of spinning up the atom, and you have to reach all of them simultaneously. So the way to do that is use the magnetic shimming coils. Hathaway, who had this machine before, and Daniel Alzafan, who was working on this, weren't using it for that purpose. They were using the shimming coils in order to detect EPR by putting a 100 kilohertz signal through it, and then you would read that on the on the reverse signal. You'd see a 100 kilohertz pulse, and you know that electron paramagnetic resonance was happening. So you'd be able to see a change in the reflected power at 100 kilohertz, and you'd know, hey, we're in resonance with this thing because now it's starting to vibrate. So that's what's going on with this setup right now. We also are about to add in a massive laser machine. Jagnar over here, say hi.
Hey, folks.
Yeah, Jagnar is building a little wooden assembly that's going to go on top of this to give us a little bit more of the holy of holies, flat surfaces in a lab. That's the hardest thing to come by in a lab is flat surfaces. So we're going to build a little space over here so that we don't overheat our tweeter again by putting anything right down on the grid where it needs airflow. There's a much more powerful tweeter down there that Tom Butler has swapped out the tube for. We haven't powered that one up yet, but we might do that in the near future. And this is the latest addition to our lab. This is a massive dye laser. So what we have going on here, we're using an industrial grade YAG, which is at 1060 nanometers. That's infrared. You know, you can't really see that kind of light, just heat. This kind of laser is actually used in industry to like do ablative surfaces. To if you've seen our APEC mug, that was made with a laser like this, where you could just jet off material and etch metals and stuff like that. So that's what this laser is. It's feeding into essentially this entire orange box over here is just a device that changes a laser's frequency, and it's variable depending on which solutions you put in here, which dyes you use. You're able to use fluorescence to go from one frequency to another, and generally you're going up in or down in frequency or up in wavelength. So for this frequency, which is in the infrared, we have a multiplier that takes it to 532, which is green. And then from green, we can go to any frequency that's higher than or higher than 532. But there's also options to go even lower more into the UV, and then you can get even higher frequency dye lasers using different dyes. And the output comes out over here, but we're going to couple it to a fiber and feed that into the chamber. This is all going to be tuned with the coils and with the microwaves. We're going to have a pulse of light that comes in first, creates the triplet states. Then the microwaves come in and couple to those triplet states, and then couple to the atom using electron paramagnetic resonance. This is called triplet state dynamic nuclear polarization, what we're doing. We also have somebody who's coming in this coming week to work with us on the lasers, and we'll be working on the terahertz laser as well. So we'll hopefully have that up and running in the near future. It's probably going to take quite a bit of work in order to get that up and running. I found somebody here in New Jersey who has like 40 years of experience working with lasers. He's never even heard of something like this. And it's not surprising. There's probably only a few of them were ever made. So, but luckily the company Edinburgh Instruments has been very helpful. They gave us over the instruction manuals. So we have that printed out. So hopefully we'll have a terahertz laser source coming in real soon. Something interesting that I learned about this laser. It came with a 67.5 volt battery, and the battery was dead. But I got another one. You can actually get a battery this big. What's it, like 3-4 inches long? That it has an output of about 67.5 volts. It's actually 72 volts. I'm just sticking that on your tongue. I can't imagine it has much current. It's probably a whole bunch of button cells that are just stacked on top of each other. But yeah, heck, that's a really small 67-volt battery. And we've also got some spectrometers up and running. This is a little toy we got from the Orient. Tells us what frequencies things are running at, and we had to. Oh yeah, we actually had to calibrate it using a light bulb that they gave us. But once it was calibrated, it was like spot on with what the lasers claimed it was supposed to be.
And this is a little spectra of those parameters for like while the software.
Yeah, this is what it looks like.
When pre-calibrated.
It doesn't look like it's live right now because normally these things jump around a bit. But yeah, just to give you an idea, you get different colors and you're able to see what the essentially a camera is showing you, and that's a new toy that we've got as well. So that's it for my update.
Awesome. Mark, thank you, sir. Thank you. Okay, I'll go back to our Brady Bunch layout there. That is super cool.
This is a frequency doubling crystal. Yeah, I don't know if you can see it in there. Yeah, I'm learning a lot of cool stuff about lasers and crystals, and I got another doubling crystal over here. It's like really small. This thing was like $300 for that tiny little crystal, and it doubles the frequency. Really cool stuff. What you can do with optics. So,
that's amazing. That's amazing.
Yeah, when she got on and was talking about what they needed lasers for their experiment, I'm like, yes, we just got it. Oh, here's
go.
up and running. Jagger got it going. And you could see the peaks, 907, 848. Those are peaks of a fluorescence light bulb.
And it's focusing right now on the infrared range, but if we flip it, as we found out with a bunch of YouTube tutorials, you'll actually see the focus, what we really want, when we zoom out here this way. So flipping it and playing around with it for a little while gets you close to like the actual spectra that's supposed to be. That requires a very consistent amount of configuration through these tools here using trim points. So you'll just set your basic fluorescent 436, 546, and I mean, if you just look up any like standard photo of what it's supposed to be, you'll find these two hit points here, and which is basically indigo and then greenish yellow. And then you have to play around with it because you'll see peaks come and go, and you'll flip with the spectra if you're focused more on the ultraviolet sides of things. Yeah, thank you. And then, of course, this is the window that you can also play around with. And I think the trick here is to just get the height.
I guess the point is that white light is not really white.
Yeah, it's a collection of a bunch of different frequencies.
Right. So they include this specific light bulb with it, and
there it is.
And you tune it to that by putting in those parameters over there and like pointing out which lines you want, and it'll align the camera with it, and you get a much more accurate spectrum.
Yeah. It's really cool how far it goes into the infrared side of things, because you can like spec this to 812 and 1092 and some other numbers that are a lot more on the other side of the spectrum, other side of things, quite literally.
That's awesome.
Very, very cool DIY little spectrometer, and very efficient for the price point. Just because of some open source software called Theramino, which is like completely available online, and you just got to figure out like little tweaks and it works.
Let me touch base with Drew. Drew, how are you doing over there, buddy?
Yeah, I'm ready. Sure.
Okay. Yeah. Well, let's go over to Drew then. Drew, take it away, sir.
Okay. We're setting up to do a whole bunch of demos to various organizations, and it's madness here in our shop. But we had a very exciting confirmation brought to us by our own Dr. Charles, who took one of my a pre-tested thruster, and basically I build 4, 8, 12 of these things a week, and I test them, and then whatever one of the batch works the best, I give to him to play around with and teach his, teach the people that work with him on this project. And he took a thruster that in my testing was making 400, 450, 470 micronewtons, and he took it and put it in another chamber, which has virtually identical dimensions. It's just a smidge bigger than mine, and ran it at the same basic pressure, something in the mid 10 to the minus 6 torque. Ran it at the same voltages, used the same sensors because we basically reproduced the Faraday shield around the device, and we reproduced the forces, and we reproduced how we test it. We turn it on and we step down in the same basic. He basically reproduced my test regime, which was easy because he's the one who invented my test regime, because he's the expert in the field. So with no further ado, I don't have this laid out amazingly well, so I'm just going to go ahead and try to do a share screen, screen sharing. This is different. Don't show these tips again. Screen sharing.
Yeah, Drew, if you can hear me, it's the present button, and then share screen, and
okay.
Should ask. Yeah.
Okay. Yeah. I'm getting there. Just share audio too, but there isn't any.
There we go. Add to stage. Rock and roll, brother.
Okay. So, yes. So, okay. So what we have here is this is my testing operation. So there's two scales here. One is the true zero, which is the first scale. And I guess I could zoom in here a little bit. So true zero is where the test article starts at. And these little steps down here in voltage they're about 1,000 volts a piece. So step down, step down, step down until we get to full maximum voltage, which in this case is 9,500 volts negative. And as we're generating, I've kind of moved the axes and stuff, so the stuff makes a little bit of sense. But when we turn on, it starts making thrust, and in this particular case, it was oriented so that it would pull against the force meter, which tricks it into thinking that it's more gravity, so it goes down. So anyhow, you can see it's only making 0.2 millinewtons at maximum voltage, which you think, okay, so he said it made 0.4 millinewtons. It only shows 0.2, but these thrusters, when you turn them off, they tend to go back up past zero and pack a whole bunch of charge into the structure. So when you turn them off and they're just in sleepy mode, they're actually making 0.26 millinewtons of continuous thrust forever. Because once the charge gets into these things, it really doesn't like to come back out. So what I did was I went ahead and took the force scale and just moved it over here to the zero. So I moved the zero from here. Because the next time you turn this thing on, it's going to be zeroed up here, and it's going to thrust all the way down to wherever it's going to go to. So, for example, if you call this the new zero line-ish, and you turn it on, here's the new voltage line. So it comes down here to around 450. So it's making about minus 450 micronewtons of thrust. You turn off the power, and it'll float right back up here to its happy zero state. Just realize that that's actually still making thrust. So if you're in a spacecraft and you turn the engines off, they're still producing thrust relative to, the 0 point of when you turned them on. So this isn't all that exciting, except that this thruster contiguously made around 450, 470, 400s, and if you leave it on a long time, it makes whatever 5 550, 580, something like that. And then when you turn it off, it changes the 0 point, but that's not important. What's important is that it makes somewhere in the zone of around 450 micronewtons of thrust continuously. You turn it on, it makes it. You turn it off, it goes to 0. You turn it on, it makes it. And then Charles took the same thruster and a completely different chamber with a completely different test rig. And this is his. Now he flipped his. No, this is in the same orientation. So here's whatever this is, 1500 volts, and whatever this is, 3000, 3500, whatever this is, 4500 or 5000. This is probably 5000. This is 6500. Anyhow, he gets all the way up to 9500, which is his power on up here, and he's up here, and he's making somewhere in the zone of around when he turns his off and it cycles back to 0. He's making. Oh, actually, he's actually got this one's actually flipped over. So he's making around 400 micronewtons of thrust. So in my chamber, it made about 460, 470, 450, and in his chamber, it made about 400. So it's a pretty good correlation considering that it came out of the chamber, sat around in a plastic bag for a couple of days, maybe a week, and then went into his chamber, got pumped down, got pumped up, got pumped down. So it had a lot of exposure. It bled a lot of charge off. The cool takeaway from this is two completely different test operations using the same thruster produced the same basic quantity of thrust in the same direction. In my case, I can flip the thruster and it'll produce thrust in the opposite direction. He did the same thing. He flipped the thruster and it produced thrust in the opposite direction. So, we've had our first, whatever you want to call it, second party validation of an actual state-of-the-art thruster, and it was ourselves, but still pretty cool.
Drew, that is awesome, man. That is seriously awesome. Okay, so sorry about that, wrong one. Okay, there we go. So yeah, I'll bring everybody back in. Do you guys want to do open discussion? Because I think that was it for lab updates. I think we got updates for everybody. So yeah, open discussion. I'll call it. Give it about an hour and maybe shut things down at 4:30 Pacific tonight. That works. Or we.
I have a tiny bit of a theoretical update / experimental suggestion. If anybody's interested.
Yeah, go for it, Brendan.
All right. So I've been playing around with infodynamics for a while. I can't stop talking about entropic gravity, as you might have noticed. But I when at dark, when it's late and I'm alone, I talk to AI a lot, and it's helped me do things that I was not capable of doing before mathematically, right? Because I'm still learning, and I don't want to go through the entire boot camp of learning everything. So it's given me a voice and helped me sort of put into the universal language of mathematics what I'm trying to express, which is everything we talk about here: vacuum fluctuations, space-time curvature, all of that in terms of information and infodynamics. So there's a few approaches to this that I'm doing, and permit me to present here. I'm still working this out. I'm still getting the code into LaTeX. I want to put this out in the LaTeX properly, but I also might want to leave a version that's half LaTeX, proper math, and still leave the codes in so people can copy it into their own chatbots, because that's just the age that we live in. So hold on, I gotta make sure that I use the right screen. Select. Oh, they're just numbered. That's really cool. No, wrong one. There we go. Okay, so this is syntropic engineering. So syntropy is the opposite of entropy. So this is your building technologies that are directly reversing entropic effects, which is the direction that the universe tends to go. Like if you break a glass, you can't unbreak a glass, theoretically. Also, like if you had like Laplace's demon sitting there and observing all the little tiny pieces of glass going all over the place, had a complete map of that, theoretically, you could put all the pieces back together, and that would effectively be the same as reversing time. As far as like the universe is concerned, as far as the mathematics is concerned, effectively, I didn't say it's actually reversing time, because like time might actually be like an emergent property, as is gravity, of this informational relationship between the past and the present, as far as we know it. Like, but that's actually more like the difference between degrees of freedom between two different systems. So, kind of working with Jacobson's thermodynamic gravity, Verlind, and bringing in the Bekenstein's bound ADS CFT correspondence. Here is pressure defined in terms of information density. So we're defining information density here. Here's energy-based information density, an equation for equating mass and information. That I didn't invent. This was created by somebody else, but we're injecting that here. Information gradients that could be used akin to gravity. And just a bunch of cool tricks here that getting information field tensor from Shannon entropy. And this is where I stopped. I'm manually going and putting this code into ASCIImath.org and getting it to convert on the fly, and then actually manually embedding these PNGs in here. And I've got dark mode going because like I can't. Who has light mode on their document? Like, anyway, it's all kind of cool. But right now I'm playing with so that this applies. So that's all well and good. We could just argue until the cows come home about what's fundamental and information, space-time, energy, quantum fields, or whatever. But what does that mean if we can't experiment on this? So I just had the robot write up this, but from my experimental design. This is my experimental design to test this. So you've got 3 sets of disks. You could make these into series stacks, basically, but like high density Blu-ray discs or high density DVDs, where you've got a control that's not burned with any data. You've got another one that's burned with completely random data. Like you could try natural random data and like computer generated random data, have a number of different tests, right? One that's all ones, one that's all zeros, one that's like built on a language, try different languages. I don't care. The point is showing that something about the informational quality you put in these when applied to a dielectric surface, and then you apply an electrostatic field, a high energy electrostatic field to that, does that make a difference where opposed to just blank dielectric material with no informational qualities? So trying to have this stupid thing draw this thing up, but here's sort of like what the stacks would look like. Of course, that like you'd have actually cat whiskers going to each one of these, and I was trying to get it to say like, okay, the data plated side is the same as the electrostatic applied side, right? And then you have structures on both sides holding it up. You maybe even be able to use those little foam inserts that come in your stacks of DVDs between these, right? And I don't know exactly how big you'd have to make that gap. I might talk to Drew about that. What's your ideal gap to not get the arcing, right? and other such things. But this is my idea for how to sort of expand on what we're doing with these asymmetrical capacitors. Were applied to, like, this is why theory sort of matters, and I think it matters at least a little bit what the fundamentals are, because if the true fundamental is information, then you'd expect that information has a physical quality when you put it in these sort of situations. And that's it. Thanks for letting me show you that. Anybody have anything to say?
I got some, Brendan.
Sure.
So when we're talking about information like that, as far as I understand it, information can come in a lot of different ways, right? And the angle that seems to have worked best, from my understanding, has been going to James Sylvester Gates with his adinkras. So he figured out that in string theory, it looks like these quantum error correction codes just pop right out of there. Like the fundamental basis of the universe looks like it's got these error correcting codes just built right in. So you can take his stuff and you can start trying to run with that and going, okay, so if the universe is doing quantum computations all the time, then maybe we should start learning more about how we're doing those computations in our quantum computers. And is there like a next generation thing that'll get us from our basic low-level computers, quantum computers, into the kind of quantum computer that it seems like the universe is? So from what I've seen from that, ternary computation comes into play in a huge way. That seems like where the next step is going to be, is in ternary octonionic error correction codes.
It's sort of funny you would say error correction codes, because I see the UAP phenomenon as sort of an error correction code for a society that takes itself too seriously. But
okay, so yeah, if it's okay, let me jump in. I want to walk you guys through some of the photo albums. I don't have videos in place yet. This would be kind of a quick update for me, I guess, what I'm working on. So let me share. Okay. And so Mark and Jared were both at this event with me last week. This is my Flickr photo gallery. Again, I have to put up 2 windows. Sorry for the delay there. Okay. So the first thing we did, we got there like Thursday, so Friday morning before registration, we went out to Glenn Tony Robertson's superconductor lab. So the important note there is Tony is technically an old timer now, right? He participated in the STAFE conference. He ran the SPCIF conference. So he's done rigorous scientific work. He worked 31 years at NASA before retiring. And he was on the NASA superconductor team that replicated Poglanov's experiment. And that is kind of the most important thing. So there are a couple of experiments that he had me take photos of. This is just a rotating graphite shaft, and it's on, as you can see the mouse here. It's on a mount so that basically if it moves, it'll deviate from center. I also got photos of superconductor samples. Here's Dr. Matthew Sadagis holding a piece of a broken one. And I did some interviews with Tony. This is, let me see if I can find a full piece. Okay. And Brendan, you might want to mute because I think there's a dog in the background. Okay. So this is the machine they're going to be using for new superconductor samples. So what I wanted to tell you about this was, again, Tony was on the original team in the 1990s. NASA started to get excited about this. In the very early 2000s, there was a story that they did a replication of Poglanov's rotating superconductor and had null results. That story is false. It was a rumor. They had Eugene Poglanov fly over from Russia or Finland, wherever he was at the time. They had Dr. Ning Li, who was working with her own team, who was kind of coordinating with them, but she was very tight-lipped. She made some claims, but she was tight-lipped about the data. And so the NASA team They built several smaller superconductors. Many of those cracked. It's very hard to make them at large size, and they did not test the superconductor. The rumor that was going around was they did a test and they made it up to half speed of Poglenov's. That's not true. They never even spun it up. So this machine that I'm showing you now is a new one, the Drytel 100, that orange thing over on the right. I believe that is a vacuum pump. Right above that, there are a couple of Marx generators that he's built. It is going to run, the high voltage will run over the top of this green insulator that's sticking straight up. It looks like a little green wall, down into that green cylinder and the vacuum chamber below it. And he is going to attempt the Poglev impulse experiment. So for folks who are kind of deep into this area, Dr. Eugene Poglev had 2 experiments that he discussed, and people mix these up all the time. That's why I'm going back to him. The first one was a rotating superconductor, where they felt that because of swirling pipe tobacco that went up above it, they felt that this was creating a column of reduced gravity. And the story in the 1990s was Poglev ran up to subsequent rooms in a multi-story building, and he felt this column of reduced gravity in the same place over the superconductor. So that's experiment number 1. In the early 2000s, he proposed the Poglev impulse generator, which used a high energy, high voltage discharge into a superconductor that was in a vacuum chamber. And he claimed that it created a burst of gravitational energy that was capable of punching holes through bricks, literally disintegrating brick, as well as warping sheets of metal up to 1 inch thick. And I believe, if I remember correctly, he said that this, when they tested it, it went out for hundreds of meters in one direction. And then in the other direction, he said that it had dangerous biological effects. And that could be from radiation or any number of things. So we were there at Tony's lab. I will have some video up. Again, Jared and Matthew Sidagis were there with me. I think that Mark was there as well, briefly. We're going to try and get more there when he gets into it. So the SCU 2025 conference, this used to be called AAPC. They changed the name. Now it's just Scientific Coalition for UAP Studies. They would not let me take photos in the conference room itself. That's kind of a bummer. I was able to do that in 2024, but I was able to get just candid moments, just the folks who were there. And for me, that helps fill in the gaps. For anybody who wants to watch those presentations, they had some amazing presentations this year. You can see those online. I would say go to explorescu.org and take a look at their website. You can learn more about it there. You can watch the presentations as downloads, and the photos are all here. These are, again, outside of the conference area, a few of them in the hallway, as well as 2 different bars, 2 different restaurants, and some patio areas. So that's kind of what we have going on. I actually have 2 sets of photos. As you can see, a lot of these faces probably look familiar. Many of these folks are presented there. Here's Rich Hoffman. Rich is kind of the primary organizer of the SCU conference, and he is a really nice person. He just kind of gets sandwiched sometimes because of presenter requirements. So that's that one. And let me go back to PhotoStream. Okay. And I appreciate you guys bearing with me. It's good to mention the highlights before I forget them. So then, also during the conference, we went to Dr. Chance Glenn's lab. Again, Mark, Jared, as well as Gary Stevenson, his wife, Nancy, and I believe we had 1 or 2 other people there. So we had a group of folks that went over. Dr. Chance Glenn is working on what he feels is space-time distortion from high energy spark discharges. I got a couple of photos. This photo I love because he is a Star Trek fan. And so this is like Zephram Cochrane, right? This is the statue of Zephram Cochrane right there. And Arthur J. Bond Hall is where he teaches at Alabama A&M. Chance is a dean. This is also a great photo. That is a photo of Chance over on the right in the blue shirt on the wall. and there is the actual man himself in an A&M sports shirt on the left. So I was pleased to get that one. And this is a close-up of the apparatus. This is very rudimentary. He has been changing things and optimizing and playing with a bunch of variables. I think once he dials it in, he'll do something that's a little bit more permanent. Right now, this is just it's a basic vacuum chamber. You can see it's got like a pressure gauge on top. It's got the vacuum inlets and outlets. Inside of it, there is just a spark gap, and I'll do a close-up there. It is quite literally a very basic spark gap. He's shining a laser through it and looking for interferometry patterns that he believes are indicative of space-time distortion. And so this is some of the equipment that he had. Again, very basic stuff. He's got, a frequency meter, just things to run it. This is part of the vacuum equipment that he used, part of a workbench for assembly. And then Dr. Glenn's lab. And he is a wonderful character and a big dreamer. He is definitely one of us. And I'm so pleased we were able to go there. Yeah, and look, and Tony Robertson was with us. That was who I was forgetting earlier. So we got the whole gang there. Okay, so those are the albums. I have video that I'm going to add for Tony Robertson. I have 2 videos. One of them, he talks more about Ning Li. The other one, he talks about some other experiments. I interviewed another fellow while I was there. His name is escaping me, who did research into the Huntsville Business Gazette story. And I can share that for you before we go today. But that one has updates from George Lee, who is Ning Li's son, talking about what happened with her. Again, a lot of, more rumors than anything else. There's good history on her health. Apparently, she was hit by a vehicle at one point on campus. She had health issues, struggling with cancer, but he does not have hard and fast data on what she developed. So that was my short presentation. And let me try and pull up the Huntsville Business Gazette. And Mark Sokol might be able to, I will share this really quick. He might be able to tell us more about Claude Power, who is a gentleman in France, a scientist in France. Claude has done a ton of stuff on UFOs over the years. Claude also did some superconductor experiments, I believe with a replication of the impulse generator. He claimed that he got positive results. He is a little bit tight-lipped about what he got, though. So this is the Huntsville Business Journal, July 30th, 2023, by, let me see, Noah Logan. So I've had a couple of emails and phone messages with Noah. I have not had a chance to talk to him yet about uncovering the mystery of Huntsville's brilliant anti-gravity scientist. So if you Google Huntsville Business Journal, Ning Li, you'll probably find it. Dr. Ning Li's son talks about his mom's career and legacy, along with the internet's obsession about her so-called disappearance. And I will scroll down here. So he goes into the story of her initial appearance, some of the claims that she made. Apparently my name is mentioned in this article. I just scrolled by it. Okay. And so if you have a really great monitor, you may not even need to visit this. You might be able to read it off the screen, but I'm betting most of us can't do that. So that's the Ning Li story. Okay, so sorry for taking you guys off topic. It's good to kind of catch up on that. My takeaways from this trip, I think the most interesting thing for me, so I had a few takeaways. Doing the work, because if you go on UFO Twitter, as valuable as that can be sometimes, it has gone into storytelling and people quoting, and there's no value there. It's not moving the needle forward, right? What you guys are doing is moving the needle forward. So one of the things I've heard several other people say this is this person doing the work or are they just talking, you know? And that would apply to me too. I just talk. That's what I do. I'm not doing the work. You guys are building it. So that's kind of one of my focus areas for this year, is focusing on people who are doing the work. And then I think another thing that was a takeaway for me was detection and tracking of UAP. And then the final thing from this conference event was maybe the case is not closed on superconductors. Again, the STAFE conference was based on the HFGW 2003 conference. Superconductors played a heavy role. HFGW was all about that. STAFE was a lot about that. And it just kind of disappeared from view. Maybe Ning Lee did accomplish more than we thought she did. Drew, go for it, man.
Hey, Tim. Dinner just showed up, so I'm about to cut out. I forgot to mention it. I don't have any particulars on it, but Dr. Charles came by a couple of weeks ago and gave his little, drive-by blast of physics information, and says he showed us the whole presentation. He's figured out quantum gravity. So he went into the QED equations and the Feynman diagrams and just endless pages of squiggles, and out popped quantum gravity. So he's all excited about this. He's going to publish a paper on it and all this other nonsense. But he said, I've been talking to you about it. He's willing to give a presentation on it here in APEC.
Yeah, that'd be awesome.
In a couple of weeks or a couple of months. We got a lot of stuff to do in the next couple of months, and then when all that cools off, and we come back from one of our presentations, then we're gonna show quantum gravity, which is kind of sad because gravity turned out to just be electrostatic pressure. But he's proven exactly how you can have an attractive only version of electrostatic pressure. So, it's, if you feel like following it, it's 20 or 30 pages of whatever, quantum dynamic calculations.
Yeah. I mean, in terms of the math, there are people, smarter people than I will have to take a look at it. But in terms of setting up a presentation for him to talk, that's 100%. And then if he'd like to do like a podcast on it, we did one before, and folks.
Oh yeah, that'd be better. That'd be a good idea. Yeah, that way he could talk about it and whatever the hell. He's got all kinds of whatever. I listened to the whole thing. I even videoed it, and it made no sense to me. But, at the end, he started with whatever, real simple calculations, and it got real complex real quick, and then it got long and stupid, and nobody understood what he was talking about at the end. So.
Yeah. Well, and then again, folks like Dr. David Chester are really good at teasing through the math.
Yep. I was talking to Jared about that. We're going to try to get these two guys to on the same. I'm afraid that the universe will implode if these two guys ever get together and start.
The thing that's cool about David is David is super low ego, right? Which is almost humorous, because he talks with other physicists, and many physicists, especially the ones that we know, are like giant egos, right? Like, without naming names, but they are always right and everyone else is going wrong. It is wrong and going to hell at the same time. And so David is really mellow and laid back, but in truth, he, again, the thing that blows my mind, just to plug Dr. David Chester for a second, most physicists have a pet theory that they're pushing, right? It's like my precious, like in Lord of the Rings, they polish their theory all day long, and they're trying to sell it to anyone who walks close enough to hear them, So David is that rare breed of person who will look at all of those different theories and compare them, and then say, okay, here's why these 5 are missing something. Here are these other 5 that need this. Here's how they all compare. And the first time he did that, I was just mind was blown.
David even read my rag and told me exactly what was wrong with it, and I used that to help correct it. and update it. He's a great guy.
Yeah. And he's really laid back. That's the thing. Like, you know?
Yeah, well, you'll have an opportunity because, like I said, Charlie's he's gonna come on, give the whole spiel, and then everybody has a shot at the physics because it's just equations. But
Oh yeah,
he did the whole Feynman thing with the little chevron squiggles and little things and virtual photons going away and inertia going back the other way, and then he's like, we got to balance this thing. Oh, there's the graviton or something that comes into the equation.
When you think about it, like, I mean, you guys are getting results in the lab. We have, I mean, when you look at the things that are going right in terms of this community, right? Like the kind of communication that we have. Like I did an interview on the on a society that started in the 1970s, and it used to be they would communicate with handwritten letters, the occasional phone call, and a print newsletter, and then they would get together once a year to meet for a conference, right? And so, like, we can do real-time video streaming anytime we want, right? And I know that you guys do. You're working with each other, and you guys have Zoom calls and phone calls and sent emails, and like, so the quality and depth of information that you're able to send, just like on a moment-to-moment basis, lets you overcome issues and work on to solutions rapidly, you know? But then you look at some of the other stuff, like one of the things that I've been seeing is you guys, all of you guys are using AI more and more and more and more. And you still have to check the work. It's not perfect. Drew's not. Everybody else is. But like
Drew's got a genius on his team, so like
yeah. The rest of us are using AI.
No, actually we did take a shot at this whole AI nonsense. But we literally said, okay, we asked a very specific question, and that thing, whatever, that program went out and read through all of the crap that's out there and spit it all back out like a little regurgitated sandwich of it. And then we said, okay, incorporate this patent, which is ours, and answer this question. All it did was give us a paraphrasing of our own patent. And we're like, okay, well, what would happen if we did this? And it just regurgitated known information. And we're like, okay, what would happen if we did this? And it regurgitated information. Okay, now, let's think about this. We want you to insert the fine ratio, or fine, whatever the hell, the 1/137 thing.
Fine structure
and then, that's it, fine constant thing. And then extrapolate the... We've spent weeks on that stupid, whatever it is, prompt. Nothing of any value came out of it. Nothing. So y'all go as far as you want with this AI nonsense. It ain't nothing but a babbling dictionary, as far as I can tell. There ain't no new information coming out of this AI.
It's not perfect, but
there's actually in Mathematica, if you're using Mathematica, there's actually a chat in there. And so that makes it a lot easier to use Mathematica and do computation. So the way AI can help us is to do complex computation. That is a useful thing for science. But yeah, I agree with Drew. What was that quote from Star Wars? The ability to talk does not make one intelligent.
Yeah. Also, if droids could think, there'd be none of us here, would there?
Yeah. Yep. And then who knows? That might happen, Brandon.
I looked at Charlie's 19 pages of QED equation, his integration. 19 pages of integration or differentiation or whatever the hell it was. I don't understand any of it. But I'm like, dude, why couldn't you just get a machine to burp all this nonsense out? He goes, no. Because as you go along, he takes the equation and he's like, oh, well, this is actually a different version of that. And he goes and grabs that and puts it in and then rearranges it and stuff, and then things drop out and things come in and whatever the hell they do. And I'm like, okay, so you're telling me that this is state of the art for physics? It's like, yeah. So I don't see how the AI thing it ain't out there thinking, and it ain't out there.
It's not supposed to think for you. It's a tool to help learn things.
I used it for something, and I came up with something really interesting. I asked it to look at all the published debunker information around the recent ones, like the Tic Tac event, and I asked it to look at researchers' publications around things, and I asked it, is it possible that people have been succumbing to confirmation bias? I wanted an independent evaluation without emotion. And it did a research. It looked at everything that people had been saying and doing, and it came back and it said, yes, people are absolutely suffering from confirmation bias on both sides. Dismissive bias on the part of the debunkers. They look at stuff, they see what they want to see, and they go, it's not nonsense. And then on the researcher side, like the MH360 video where there's these twisting spheres, that's a confirmation bias, or and another type of bias where you're acceptance bias, where people are accepting things without doing enough research to determine whether or not it's real. So both sides are suffering from confirmation bias, according to AI. And people need to do a better job of their research before they open their mouths.
So Brandon, getting back to your
you had a question
presentation
about my stuff.
About entropic gravity. That, when you brought that up, it rang a bell, because my advisor back at UC Merced, Roland Winston, back when I was doing my PhD, this was 2008, 2009 timeframe, he was really into entropic gravity. So we did a lot of work in that. And it was popular for quite a while, right? It was a popular thing. But at the end of the day, that's not something I'm pursuing. I mean, I don't know what to tell you.
You've said this before. I'm still going ahead.
Yeah. I'm not trying to dissuade you or whatever, but it's, Roland, he was a serious physicist, right? He was somebody he was Chandrasekhar's student. He was the chair of the department of University of Chicago before he was one of the founding professors at UC Merced. So he's not someone to take lightly, but he would come to me to talk about GR, right? And those kind of concepts. And in fact, back then, I think that was when they were having these experiments where they thought they found something that was going faster than the speed of light. And it turned out what they were doing is they were driving an atomic clock to the second site and trying to do a one-way speed of light. But they weren't taking into account the relativistic effects of motion and how that changes the clock. And once you did that, basically you're not going faster than the speed of light. So, a lot of times people aren't understanding GR and understanding what it really means. So one thing,
but it is a tiny demonstration of the twin paradox, sort of.
Yeah, and that's long resolved, but I know it's still out there. There's so much misinformation about that. But the thing about GR, so if you look at the book Gravitation, I'm sure you don't have it, but actually, when Roland passed away, his sons, they gave me his copy, which is great. But there's various ways to derive the equations of general relativity. But the thing is, when you're doing physics, you got to realize that there was a motivation for doing that, right? That's the fundamental principle, which is general covariance. That's what Einstein was trying to get. Now, all these other things that kind of like can mean the same thing or like connect, that's consistency, but that doesn't necessarily mean that is what's happening. So, in terms of like the physical logic and thinking, it's like I said, it's hard for me to like tell you for sure. I know that entropic gravity, that point of view of things, is not fundamental. I don't know that, but it doesn't, like, I don't I didn't find any physical motivation to take that idea. Now that idea, like I said, there could be tied in to these higher other concepts, right? Conceptually, or when you think about things, you can find parallels and stuff, and that happens with a lot. We have a category theory, right, where you can look at patterns in mathematics and have a kind of like a higher level thought about categories. And same thing with topology, right? Topology, you can have these basically concepts that are not necessarily physical or real, but you can have something where you have descriptive or conceptual models, right? So it's really the trick is when you're doing physics is to figure out, okay, what conceptual models or thinking is really physical and what is not, right? So there's mathematics. There's a lot of mathematics, but mathematics is not physics, right? Mathematics, some of it can help you describe the physics, but the physics is really not the mathematics, right? They're different things. So anyway, that's all I wanted to say about that. I think it's great that you're looking into it. But again, I would look at like all the different ways to derive GR. And I'll give you one example. So one of the presentations, what was that fellow's name? He goes on here and he presents, and he does this presentation where in his presentation he had assumed basically the radiation, right, the Hawking radiation in his theory, and then he said, oh, by the way, I end up with gravity. Well, if you have Hawking radiation, you have to have some form of general relativity in there, right? Because that comes from deriving Hawking radiation comes from a black hole with quantum mechanics kind of joined in, right? So one of the things I would say whenever you're looking at these things, just be cautious of your fundamental assumptions conceptually. Do they already have the thing that you think you're deriving? And anyway, that's my comment.
Those are great points, and I appreciate all of it. That's wonderful considerations. Yeah, and it's not like a pet thing either. I think it is testable ultimately if information is close to the fundamental structure. If that matters, then there should be a difference between surfaces that are charged with information or not.
Understood.
No, but like that's amazing. I think that Ted Jacobson, who was one of the main pushers of the theory a long time ago, was talking to Kurt Jaimungal about it, and Kurt was like, "So you really think, thermodynamics is the basis of all this?" He said it's more like he's not really sure what the basis is, but he had a hunch that whatever it is, thermodynamics seemed like as good a place as any to start to like try and mathematically map it. And that's where he was coming from. Also, the thing with the black holes is that, that's the source of the original math and some of the original assumptions, but you don't necessarily need that. And I think a little bit has to do with this ER equals EPR entanglement in the direction of motion, and that's being caused by wormholes. There's an informational loss in wormholes because of the no communication theorem and a few other things I don't fully understand. But it's complicated, but making a comeback.
And those things you don't understand, I would be very cautious of.
Yeah.
So the ER equals EPR and all this other stuff where people are stretching these conceptual, especially with quantum mechanics, where the quantum mechanics, the fundamental thing is, hey, we have a descriptive formulation of reality and we don't really know what's happening underneath, but then we start talking about what's happening underneath and having some hypothesis in there. So really it's like, I understand that it's fun, I'm not discouraging it, but
don't build houses on a bed of sand. Make sure check your foundations.
In terms of strict physics, like I talked about, I mean, there's experimental experiments that show that quantum mechanics isn't fundamental out there, and it's still like, okay, well, we know quantum mechanics actually works. It works really well in its domain, right? But once you get higher energy and you get nonlinear, things are out the window. So that's just that's something that I think, you know, I get kind of surprised because, like, you brought up Kurt, right? His interview with Roger Penrose. And one of the things Penrose is sitting there saying, quantum mechanics is just wrong. It's like, where's the news headline? You know, you know, there's so many people that like are thinkers and physicists that understand this, but I just noticed that it's just ignored. Like most people, well, I mean, we know it works. Yeah, it works, but then what does he mean by it's wrong, right? It's wrong in the sense that it's not fundamental. That's the thing. So it makes things difficult when and for me, it's like really, I kind of feel fortunate. It's like there's like a magic trick that everybody's trying to figure out, and I get to spend some time over here figuring out the reality. So, yeah.
And then maybe sometime after we figure out the structure of reality, we can invent a Band-Aid that actually stays on a 5-year-old's toe.
It's like how do you make a toothpaste not taste bad after drinking some orange juice, right? It's not possible. Be right back.
Has any of you done any work on the topic of phase subjugation? Sorry, phase conjugation. Because someone talked about entropy before, and what I've read, if you do the so-called 4-wave mixing with phase conjugation, you can achieve results that look a lot like exactly J-Rod. Exactly. There you go. Microwave phase conjugation. So you can basically retrace the path of your waves, and that looks like entropy reversed. Like, I don't know if anyone's familiar or wants to comment on that.
I know that some people have been looking at how you break time symmetry, right? For CPT symmetry, you can break time symmetry because I'm not great at this, but it's something to do with the chiromagnetic field. You know, when you have time symmetry, you throw a ball, it goes this way, you can run the clock backwards, it follows the same path backwards, right? If you give it a spin, so it's a curve ball, right? And it spins, it's going to go that way. You do the clock backwards, it's going to come back this way. Well, when you do that with a magnetic field, as far as I understand it, it follows the right-hand rule both ways. And so you have this time symmetry breaking with magnetic fields. So as far as, I forget why I was bringing that up, but I want to say that phase conjugation has to do with, in La Violette's book, that's not what he's referring to. He's referring to it as a way to build up a soliton, a standing wave, right, and get really large energy densities in your single wave, as just kind of like a parametric amplification thing. But when you start going into some of the deeper math stuff, deeper physics stuff, this breaking of time symmetry seems to be a recurring theme.
Yeah, and apparently that's exactly what you're doing. You're putting all your energy into your wave, so you don't have to store it anywhere because the reality takes care of it because it doesn't go anywhere. It just remains within your soliton, within your vortex.
The one thing that I'll say about the storing it in the wave is that it's a standing wave, which means there's a resonant cavity, right? It's reflecting off of surfaces back and forth. And every time it reflects off of a surface, you lose a little bit of energy, right? Or a lot of energy if it's attenuating it a lot. And so the idea from La Violette is, well, if you can somehow feed back in the reflection and match the phase, you might be able to overcome the losses from that attenuation in such a way that you can start amplifying it over and over and over. And I guess that's kind of like how lasers work, right? Like you got all this light that's going back and forth in the crystal, and it's amplifying with, you know, the reflected light back and forth until eventually it gets to an energy level and it punches through.
And I just wonder where magnetism comes along. Like, what's the role? Because everything phase conjugation deals with electricity, but where's the magnetism? And, you know, maybe what connects the two is the Searle effect, because apparently I've read this wonderful paper years ago. I don't remember the title. Don't even ask. But it was about how the concept and how the mechanics of phase conjugation can be used to explain at least some of the effects of the other Searle effect generator, the Roshin and Godwin machine. That one. So it was probably the same, you know, the poor man's SEG.
I saw the Roshin Godwin machine in person. It's a little bit different than a generalized Searle effect generator, because a generalized Searle effect generator isn't on rails, right? The rollers are allowed to like go around, and they have some freedom, right? So what I've seen with my friend Isaiah Ritchie's Searle effect generator segs that he's built, what I've seen in those is that as all of these rollers are going around one way, you get these slight inconsistencies in the acceleration. And so what happens is they'll kind of bunch up a little bit, and then you'll get gaps backwards. Well, you get this forward going wave of bunching, and you get a backwards going wave of gaps, right? It would seem as though there is some part of the seg effect that has to do with the reverse going wave, right? That at certain resonant points in this device, when all of the rollers are like going so fast that they're just floating just barely above the ring, right? Because the centrifugal force is pulling them out, right? And so there's very little friction. They still have a tendency to kind of bunch together like that as they're going around, because eddy currents and non-linearities abound. But it's reverse waves where you tend to have really interesting effects. In material vibrations, there's something called Lamb waves, which are just mechanical waves in a medium, but usually at higher frequencies. Well, when you look at backwards Lamb waves, you start getting a lot of magical things. You start getting extra amplifications, extra nonlinearities of this forward-going wave is now somehow accelerating the reverse-going wave, right? And so it's exchanging some of its energy. And so the backwards wave, there's an asymmetry there. The backwards wave ends up getting more energy from the forward-going wave. So in the seg, that backwards gap wave, soliton wave going round and round, ends up gaining more and more energy that way from the forward-going effect. But I don't know how the phase conjugation goes together unless somehow you match those two. But if you match those two, you lose your asymmetry, the forward-going and the backwards-going.
The concept there is that the magnetic walls are providing you with some kind of a resonance, because the SEG is circular and the magnetic walls are also circular and they're concentric. So the idea is that maybe they're providing, you know, a shape that can induce some kind of harmonics in the frequencies, and that amplifies the whole magnetic field thing. Yeah, I remember that. That was from the patent, right? Yeah, I think the Roshin and Godwin patent. Not sure.
So the Roshin and Godwin machine, according to those guys, the inventors, it could lose like 27 to 30% of its weight. According to the people who acquired it later and tested it later, they were only able to verify a consistent 7% weight loss, which is still something for something that big, right? That's a lot more than, you know, a micronewton. But it's when you have things with moving parts like that and you're trying to measure weight loss, it's a nightmare, right? Because you got all these other things that you got to get rid of. Yeah, in fact, Brandenburg, our APEC veteran, Dr. Brandenburg, who's all about the nukes on Mars stuff, he worked on that larger device.
Did he run it above the RPM limit that the inventors did? Because it was not too much. It was a few thousand turns. I mean, it wasn't
100.
that much.
So there was 3 resonant points for the Roshan Godin, and it was at like 550 RPM, 700 RPM, and 800 RPM, or something like that, right? And those 3 RPM nodes are where you would see the weight loss. And so at 500, you'd see like 1% weight loss. At like 700, you'd see like 2.5 or 4% weight loss. Then you see the max weight loss at like the fastest one, or something like that. Now, with Isaiah Ritchie's stuff, what he's observed is that if you follow Searle's designs to a T, you don't get more than about 300 RPMs before these rollers fly off. So that's part of the way that Roshan Godin machine was able to operate at those speeds, even though its rollers are so much heavier. So yeah, they should definitely be, and it's bigger. They should definitely be flying off. Well, they're on rails. And so that's why they're able to go faster. But I don't think they tested it above like 1,000 or 1,100 RPMs.
Yeah, see, because the only invention that I'm aware of that uses discs or rotating things are the patents of Mr. Wallace, Henry Wallace. They're little known, and they're using discs made of a particular material, and you are juxtaposing those discs, and you're sandwiching actually your disc with 2 other discs above and below it, and you counter rotate them. So the outside discs are rotating one direction, the central disc rotates the other direction, and they have to be like very close to one another, like a few microns, and that's the difficult part. And I wonder how he achieved it in his prototype. But anyway, apparently if you do that, you're pushing gravity. That's what the patent basically says. I haven't verified that.
Just to go back to this for a second. So you were talking about the phase conjugation, just so folks know what we're looking at. This is from Paul LaViolette's book, and this is where he's showing that you have your like outward going signal. It comes into receiver, and the receiver like I don't know, sends it back up here somehow to reflect around. I don't know.
And in this case, the receiver could be the hull material of your craft. So if you make a disc, for example, and you make its belly out of a material that does something with this microwave, you get all kinds of propulsion or absorption or whatever, and that's that we're entering the territory of metamaterials there, which is basically magic, sorcery.
As far as the whole receiving reflected signals, it seems as though these craft oftentimes are surrounded by very strong fields of some kind, whether it's electrostatic or it's magnetic or it's gravitic. There's always some kind of strong fields associated with these things. Well, if you're trying to do phase conjugation, which is like, precise, and you got all these strong fields that are messing with your signals. Hey, I was looking for an amplitude of this amount. Now my amplitude is like different. I was looking for a frequency of this amount. Now my frequency is shifted by this amount. Right? It can mess with it in all these different ways. So like radar phase conjugation, like that kind of thing, like normally the other aircraft that you're like pinging with that kind of stuff, right, repeatedly, they aren't like charging up the surface of their aircraft like a ton, right? The surface gets charged from flying, but it's not like they're actively have, thousands of Tesla or millions and millions of volts on the right. So I don't know. I don't know about the phase conjugation stuff. I think he, like most of us, found something that started leading him down that rabbit hole. LaViolette did. And he kind of created like this whole idea off of it. But there's a lot of ways to skin the anti-gravity cat.
Yeah, actually, what you're saying is very much correct. Like this theory is at odds with what we observe in ufology with the field. If it's messing around with our electronics, imagine what it does to a precise frequency modulated thing that depends on having your beams sent out one direction and then getting it back. Yeah,
this is why I was very interested in what Chad was saying about the like weird modulated radar signal that they were getting from the UFOs that were like staccatoed returns or something like that. Because for Mark's stuff where he's doing Alzaphon, all of that comes, a good chunk of the idea of that comes from this 1957 radar hit where this radar airplane was pinging a UFO and it was getting a certain signal, and that signal had certain characteristics like a beat frequency, and it had like a tiny little range of frequency that was operating in, and there was all these different little things to it. Well, if these craft have like fields around them that are messing with signals, is it possible that return that 1957 aircraft got, is it possible that return might have been modulated somehow by all of this stuff? So for Mark's stuff, if we take it at face value, it's like, okay, well, this actually lines up really good with the materials it looks like they're using, with the theory of dynamic nuclear orientation that, like it lines up really well. But that requires one assumption, which is that it's a clean signal that the aircraft was picking up, that the signal hadn't gotten modulated somehow by whatever's going on the surface of that craft.
Yeah, very good point. You might be receiving something that is different from what you initially sent out.
And Mark's got the book right here.
Yeah, I don't know how they recorded this back in 1957, but this was the predecessor of the AWACS. They had a whole bunch of RF detection equipment and recording equipment. So this was probably going on to some squiggly line graph making machine, because I don't even think magnetic tape was a thing back then. Mm-hmm. But what they said was frequency of 2.995 megacycles or megahertz, pulse width 2.995 gigahertz, if you put a point in there, pulse width of 2 microseconds, pulse repetition frequency 16 hertz, sweep rate of 4 RPM, so it was sweeping around 4 rotations per minute, vertical polarity, and the signal moved rapidly up the DF scope. I don't know what DF stands for, indicating a rapidly moving signal source. In other words, an airborne source.
So you have a lot of confounding factors potentially at play here. You have a dish on a moving aircraft, and that dish is spinning around at 4 hertz, right? And then the signal that thing is sending out itself has a modulation to it, right? It's sending out these pulses of radar and listening for the echoes, right? And then those echoes themselves are hitting this other UFO that is like, zipping around fast. And I want to say that incident, like they tracked that thing for 3 hours, and they were tracking it from like Louisiana, southern US to like mid US down over to like Texas. And it was flying a large area, and they were tracking it throughout all. They'd lose it and they'd pick it up again. They'd lose it and they'd pick it up again. But yeah, if that UFO has rotating magnetic fields on it, which is super common observation, well, if you send a radar signal at a rotating magnetic field, depending on the strength of that field, the speed of that field, the polarization of that field, all those things could take your little radar pulses and like mess with them, right? Yeah. So there might be parts of that if we were to dive a little deeper into what exactly was the specs of the radar equipment on the AWACS, the pre-AWACS, we might be able to come up with a general ballpark for what's going on with the craft. Because one other thing I'll mention. So the rotating magnetic fields on UFOs, here's a nifty little tidbit most folks don't know. That's been measured for how fast it's spinning around. And it just so happens that it correlates pretty well to two other observations. So it's spinning around at somewhere between 0.5 hertz to 2 hertz, right? So, twice a second or once every 2 seconds, right? That range. Well, when you look at UFOs where there's a string of lights that are rotating around the thing, guess how fast those are going? 0.5 hertz to 2 hertz. Last thing I'll say, in a very small number of incidents, you can see videos of some flying triangles and a couple saucers, but I prefer the triangle ones, where on the center underside, there is a ball of plasma that is cavitating at 0.5 to 2 hertz. So there might be something to that very low frequency rotating magnetic field with rotating lights, with cavitating plasma ball, fusion ball things underneath, like all of these things together kind of start hinting at that. Not to limit us though, that is the only frequency that these rotating magnetic fields are operating at, because there's other incidents where we see very, very fast rotating magnetic fields that are messing with electronics.
So it continues and brings up some other cases. Bottom line is they're doing some back of the napkin calculations, and the energy level is around, that they estimate is around 1.5 megawatts of power coming off the craft, of RF energy coming off of it. There's a lot of assumptions thrown in there. But we're talking lots of power coming off of this thing.
That is a nuclear reactor on board.
Oh, you don't
supposedly.
You don't need a nuclear reactor, but it's a lot of energy.
Like RF power is different than like regular power, right? So if you're talking like 10 or 100 watts of RF, right? That is not the same thing as like 10 or 100 watts coming off of a light bulb.
It depends how the RF is made.
But that is more directed, right? The RF supposed to be, directed and going in one direction. So if you get all those 100 watts from a light bulb and you put that into a 100-watt laser, it will burn a hole through your face, right?
Yes. So it could be a small fraction of that, because it's possible that they have that much energy only going in a small strip around the craft. But yeah, basically the back of the napkin calculation is megawatts of power, but there's a lot of assumptions in that math. It could be much less than that.
That's J-Rod. You said it was measured. The field it was measured. Can you tell us a few things about that incident? It's very interesting.
About the frequency of it?
Yeah, of the field. Never heard that.
So I have a lot of UFO data repositories that I dig through all the time. And so I'll think of a good keyword and I'll just search for every single instance. So, per second or hertz or something like that. And I'll go through and I'll find, 100 instances. And out of those, maybe like a dozen or 2 dozen will be useful ones, right? And in those, that's what I came away with from that, was there's these incidents where they've identified these magnetic fields that were rotating that frequency. Now, for actual data, there's only one that comes to mind, although if I think about it longer, probably more would come to mind. So Ray Stanford, he detected simultaneous magnetic and gravitic fields coming off of these craft, changes coming from these craft. So in 1978, he had this monitoring station that he'd set up in some farmer's orchard or something, or maybe near the White Sands Missile Range or something. I forget. Anyways, so he had it sitting there, and these two Tic Tacs came together and started tumbling together. Well, that's not great for data collection because they're two objects and they're tumbling, so it's good. Whatever. But from that, on his roll of paper that is, getting the little pencil arm moving from the gravitometer and the magnetometer, they go through, and afterwards they go and they do some fast Fourier transform on that. And they identified that there's a couple of frequencies where you got simultaneous magnetic and gravitic changes. Those frequencies was 6.1 hertz. It only went up to 20 hertz because the equipment, but you had these 4 big spikes. The largest spike was at 6.1 hertz, and then you had 3 more spikes that were all about the same amplitude, and that was at like 10 hertz, 12 hertz, and
I raised up
14 hertz.
I went to a square wave. Raised. I'm starting to.
Mark, can you mute?
Yeah. Oh yes.
Do we know how far
We're modulating the chamber. We're hearing a buzz.
No pun intended. Yeah. So do we know how far those Tic Tacs were?
What their altitude above him was?
Yeah, in one direction.
I spent 2 days with the guy, and he told me the story at least 3 times because, it's a good story. And he showed me all the data from it. I'd have to go back and look at my recordings of those conversations to know for sure. But I want to say it wasn't super high. It was probably 1,000 feet to 10,000 feet, something like that. I want to say it was lower than higher. He said that they had kind of tumbled through. He got some pictures of it too, I think. Yeah, I think he got some pictures of it. And those pictures are really good because you can see how the fields of these two interacting tumbling Tic Tacs are starting to overlap with each other.
Like magnets, if you bring them close.
Yeah, but I think the way they were tumbling was like birds fighting in the air. But they were not birds, they were Tic Tacs.
Yeah, or whatever they are. But yeah, that's interesting because from that book, UFOs and Water, some cases can the way they are told are telling us that the field is actually stretching for a long distance, and that can help us track these things if we know how far it goes. And apparently it does. It doesn't just stay in the bubble or the barrier or whatever it is. It goes out, spreads out a lot.
So another capability that it seems like these craft has is very long range detection. They can detect stuff a lot farther away than we can. So one instance of this, somebody that I know that's got implants, that has tested their implants, we're able to figure out the power level coming off their implant. And in order for that power level to be useful for sending out information, right? It was extremely low power. It was above background, but if background is minus 80 dB, it was 10 dB above background. So it was minus 70 dB. It's still extremely low power. So for something to be something of human technology to be able to interface with that, you're talking maybe 5 to 15 meters at most, right? Well, there's only 2 instances where that might be useful. One, you get this other type of UFO that is looks like this. It's like a long, skinny white arrow. And it can be a meter long. It can be a quarter meter long, right? But that's the general shape of it. And these things fly at a few thousand miles an hour and they'll zip past somebody. And that's the general idea on what these things are being used for, is they'll pick up some of that info. But that doesn't make, from an engineering standpoint, that one doesn't make as much sense to me as if you had satellites or you had UFOs that are in orbit, right? They're really high, but they have squids on board, superconducting quantum interference devices, right? really, really sensitive things that they can direct exactly where they know they need to direct it, right, at the person. And those, they could probably measure it from a long ways away.
Or from the underground, for the matter.
Or they're flying through the crust of the earth, because we know they can pass through solid matter, and they just fly under the house and sit under the house. But normally when we hear of encounters, like the UFOs are observed, in air, not like diving into the ground. If they dive into stuff, it's usually in the side of like a mountain or something.
Mm-hmm. Oh, yeah.
So like into a lava hole or into a holographic wall or, whatever.
Yeah, and then there's usually, this usually happens where hotspots are. So it begs the question, maybe there's an entrance to some environment that they're using inside those mountains.
So there was one book that you mentioned that I wanted to get the title of again. It was the Sphere Network or something.
The Sphere Network. Yeah.
Yeah. So I think that's the same guy I'm thinking of. Some UFO researcher figured out that some of these orbs, like the ones you were showing, some of these orbs seem to be controlled by a very old AI on Earth. And these orbs are kind of like a defense network kind of thing. They'll go and intercept. Yep. That guy. Yeah, I love his stuff. I absolutely love it. I'm not going to, put my hat on and say 100% true, but it tracks with a lot of observation.
It's the dominant theory right now. So until we have something better, that's what we have to go with.
Mm-hmm.
Yeah, if we ever do,
But those orbs, if we were to start tracking the directions of those orbs and the locations of those orbs, we'd probably find the bases. Now, I already have a map that I've started making from purported underground base locations, and something just wild that popped out of that was you'll have a base in like Alaska and a base down in like Chile, and you'll just draw a line on a map between those two. And then right smack dab in the center of that is another purported base location. And so as you start doing a global map of these things, what you start observing is you'll have all these different potential base spots. And if you just draw a line between the bases, you'll see that if there is a base, it will fall on a line between other bases.
Yeah, so it's a network again.
It is a network, yes, with like very precisely chosen locations that, and then on top of that, I mapped just for the US data is all I had, but I mapped UFO sighting locations against these paths between bases. And it's noisy data. It's noisy because these craft don't just go on the flight path, right? They'll fly all over the place, just like a regular, if you watch a flight tracker of all the planes flying around, right? They don't follow just the main paths. They'll fly all around, right? But still, there's a lot more on the paths. Yeah, that's what came out of that research, was that there is more UFOs on paths between these bases than just random, smattering chance.
So you can predict where the next hotspot will be, even the ones that are less known.
What you can do is you can predict like somewhere along this many thousands and thousands of kilometers, path between bases, right? You're more likely to see a UFO along that line than you are, very far off of that line. So if you take that and you look at, the spots where people see them, oftentimes populated areas, but there are some areas that are not so populated, but do have a lot of sightings. And it's those spots that I would be most interested to see if like those are little like smaller mini bases for some of these spheres, right? So maybe the saucers are flying out of the bases, but maybe they got a ton of small little caches, small little areas where these sensor spheres can just pop up out of the ground and like go looking for stuff.
So apparently those spheres are operated from underground, but they are not all of them. They're not all of them controlled 24/7. Like it seems, according to the books, that some of them are dormant and they're waiting for activation from other spheres. And those other spheres are basically the guardians, the sentinels, and that's That's the magic part. That's the gist of it. That book will tell you that the outposts for those spheres are the so-called haunted houses, and they're not haunted. It's the spheres doing work there, monitoring. And when a human approaches, they will simulate all this paranormal activity to drive them away. That's a very interesting take, because it shows that there is a science behind all of these paranormal effects, and they're not very paranormal after all. Just the spheres creating a diversion.
So I haven't watched a whole lot of the show Skinwalker Ranch, but I just met with one of the members of that group at SCU, and he was saying, oh, the new season just came out. You need to watch just the first episode. Like, if you watch nothing else of the whole show, just watch the first episode. It's like, okay. So I went back to the hotel room right then, that night, and I watched the episode. They found something really interesting. So on this ranch, they got this one area that they've already identified in a lot of different ways is super weird, right? They've shot rockets up, and the rocket will go and like come down and like sit on something 1,000 feet above the ground for like 10 seconds and then fall down. They'll like do lasers up to this spot, and the laser will just stop, right? So it's a weird spot. So in the first episode of the latest season, they get on like a helicopter, and they got a bunch of ground sensors, and they get on this helicopter and they fly through this area just back and forth, back and forth. And what they do is they map out this dome that the top center of this dome is right where the laser point would stop, where the rocket would like land on it. But this dome extends, like, I don't know, 500 or 1,000 feet like diameter, and it goes underground too. They were able to identify that it goes underground too. And it's just this really weird like place where electronics don't work, right? The GPS signals get all messed up. And all of the ways that these different signals are getting messed up and these electronics are getting messed up was kind of the same way. It was as if it was your time signal for the GPS coordinates. That was the thing getting messed up. And so like the GPS would lose that and then say, okay, no signal, or it would get corrupted in just such a way so it looks like you're jumping around in all these different ways, right? So it might be that some of these paranormal stuff that you're talking about, or it might be that some of these caches, right, where these orbs may be, they might have some other characteristics about the local environment there that's very unique, that is a prerequisite for why it can have a cache there, why it can have a group of orbs just sitting underground waiting to launch.
Better than usual.
Yeah.
This is why they need one of our chronometer warp detectors.
Chronometron warp detectors.
Yep, that's a battery-powered atomic clock, 2 of them that are both synced up to an oscilloscope or something, and you're able to see the Fourier transforms move back and forth if there's any chronological anomalies. So just like a GPS would move you around if the time was off, these would show it on a graph.
They need to carry atomic clocks through the bubble force field wall, right? Or move them, in tandem together through that. They need to do some experiments to be able to identify, okay, so it's messing up the time signal. How much?
Yeah, and what intensity. Yeah, and then you'd have one of them stay in one spot and the other one moves around, and you'd get a reference between the 2 atomic clocks.
Yeah, always you compare. Eugene Podklednov did that as well with 2 atomic clocks. Yeah, that's right. Mark, are you making these yourself?
Yeah, but we're waiting on Jeremiah to do the power supply to go from the battery to the atomic clock. Jeremiah specializes in making things really small. So he took on that task. And we also need, since you're using a battery, the voltage is dropping, and you need to keep constant voltage for the atomic clocks. You want to remove the voltage input to the atomic clock and all of that as a variable. We want to nail that out, and we want it to be as small of a package as possible because it's battery powered. So
it's like this big. Can you go grab one, Mark?
Oh, sure. Grab the whole box. Where's the chronological atomic clocks? You put them in the back?
You can make so small atomic clocks. That's great, man.
It's a 10 megahertz rubidium reference, like you
15
use for calibrating.
It's a 15. These are 15s. Yeah, I wanted to get the 10s, but they didn't have them. 10s are more useful because a lot of things go to 10.
Everything. Yeah.
Everything references to 10.
But yeah, it's like a rubidium reference that you use for calibrating electronics. It's just like normally, oftentimes those things are big, right? And they got like an oven inside and you can't move them and they're super, well, thanks to modern technology, they have gotten much, much smaller, like this big kind of thing.
Yeah, I got to find them. We probably stuck them in storage. B7?
D. He isn't there.
B7 will be over there. Let's see. No, they're not here.
Oh, right here.
Oh,
See, they're so small that you cannot find them.
No, this is not it. No, that's different chronometers. No, they're in a box somewhere. They're about the size of like a thick wallet, like 3 by 4 inches or something like that. It's floating around here somewhere.
It would be worthwhile to find a rumored haunted house or haunted area and try them when the paranormal activity is supposedly spiking. Because, apparently it's not always the same level. It spikes, it comes and goes. And according to the sphere network, it tells you that, that's because the spheres are not working all the time. They are monitoring, and when they detect something foreign, something that they don't like, then it's when they activate, and you observe all these weird effects.
I'm totally on board with that. I think there's a lot of uses for this particular device. Skinwalker Ranch should definitely have one. We're making a version that's going to be fiber optically coupled, so that you wouldn't have to worry about electrical conductive cables going between the atomic clocks. Because if it was a static field, if you're going into a static field, you wouldn't want to short that out. You'd want to, leave that alone and allow the system to just measure what's there without interfering with it.
So this device is something that some ghost hunters use. It's called a tri-field meter. It lets you see electric, magnetic, and electromagnetic, like RF. I have taken this to some spots and done some tests with it. I'm not like a ghost hunter guy, but if I know I'm going to some ancient ruins, I put this in my pocket, right? So I've had a couple instances where this thing does weird stuff, right? So I went to a couple different places and times. I went to Mexico and some ancient ruins in Mexico, in different spots around Mexico. And I took this with me, and I'm walking through, not looking at any of the good stuff there. I'm just walking through, looking at this thing. And it has a logging function, so you can go back after the fact, right? So you have GPS on your phone in your pocket that is tracking your path, so you know at what time, where was I? And then this thing has a time logging, so you see, okay, so at this time, I was in this spot, and this thing went ka-ting, right? So yeah, I've had a couple instances where the electric field specifically just skyrockets briefly for, maybe 10 seconds, right? For a long enough amount of time for me to go, wow, but it's not permanently there. But in both of those instances, it was high strangeness. It was you feel the cold brush, coming by it. It's oh, what's going on here?
Right. Wait, you said you also felt something cold? Oh, Mark, show it.
Hey.
Nice. Wow, that's an atomic clock.
This is a rubidium atomic clock, or reference, or whatever you want to call it. Yeah. And let me put my laptop down and show you what it's going to look like. So this is a analog video output for fiber optics. So we were planning on sending the signal out with this, and this is the little lithium battery that's going to power it all. So it'll be like a package of yay big. and then the electronics thing, Jeremiah's electronics thing is going to go like next to the battery or something like that. So the whole contraption would be about, fit in the palm of your hand. That's the hope, at least.
Yeah, it's portable. It's portable, and
yeah,
and
you want it as small as possible. So you got two of them. You got one of them inside the field, one of them outside of the field, and you're measuring the difference.
And do those go to the oscilloscope then, or do you not need one?
Yeah, you could send it to an oscilloscope. That's the easy part. Any basic oscilloscope can handle 15 megahertz signal, and you can look at the Fourier transforms and see them moving if there is any change. That's the easy part. You could even do that with a Raspberry Pi. The tricky part is getting all that data in place.
So they make little handheld oscilloscopes that do data logging.
Like I said, that's the easy part. The hard part is getting Jeremiah off his ass so that he actually makes us the electronics. So let's concentrate on the hard part.
Because like Mark was saying, like it's a reference, right? So you need your power to be super constant. And the battery power isn't super constant. It kind of changes as the energy of the battery goes down over time.
Right.
And then you also need to find yourself another dome.
Another what?
Another dome. This
energy
field.
dome, like Skinwalker.
Yeah.
Oh, we got lots of things to test, including experiments that we've already ran. We want to rerun them again with this device in the system. But there's no shortcomings of haunted houses, energy domes, energy force fields. We have our the 3M force field experiment over here, which I haven't given you guys an update on. But here's the 3M force field experiment. We're almost done with the expansion of the rollers. They're now up to 21 inches. There's just some more work that needs to be done on the bottom to hook it up to the motor. But I'm excited about this version of the experiment to see if we get a difference when throwing one of the atomic clocks through it. See if there's any change over there. This isn't as accurate as a cesium atomic clock, but those are much larger. And the value added of having one of those is not very significant. Also, atomic clocks are rated for their accuracy in terms of 10 to the negative 9 over absolute time. So there's a reference clock that is absolute time, and then how close are you to that? We don't really care about absolute time. Because all we care about is how close the two clocks are tuned to each other. That's all that matters. So if we have a whole bunch of atomic clocks and we can categorize them very well and find matching pairs, the level of accuracy of our device goes up by several orders of magnitude, because all that matters is how close they are to each other. So even if they're off by couple orders of magnitude off of absolute time or whatever the reference of time is, we're still going to be negative 15 between the two of them, which is great.
Yes, I get it.
That makes sense.
Yes. It does definitely, because of resonance, right?
Yeah,
So
we're looking for like a beat frequency between the two, or like if the Fourier transform moves a little bit.
See, that's the thing. That makes it pretty easy to measure one such field in a haunted house, for example. Maybe we shouldn't call them haunted, because maybe they're not haunted at all. Maybe it's just the spheres working. And J-Rod, you mentioned ancient ruins. Well, the ancient ruins were made by huge blocks of stone. Right, so and they were probably underground as well, cave systems, everything, and that is a very good way to mask any electronic emissions that you may be doing there locally. So maybe it's not about the ruins. Maybe it's about their usefulness in making you stealthy. Go on.
So the two places where I tested it at, one was like the largest port of the ancient world in like Central America, right? So like this was a major like shipping trading hub for naval vessels like 1,000 to 2,000 years ago, right? And that was the one where I had the strongest response on the thing, with like the cold brush thing, right? But then the other place I went was the pyramid, Chichen Itza, where you can like go up and clap and you hear like the bird sound coming from the top thing. So at that place, I only observed it on the very outskirts, on the very edges of the whole area, right? Throughout the rest of the area, I never like really got good hits. I got like a low medium hit somewhere in the middle of it, but I got a decent hit at the very outside edge of the whole thing. So once again, yeah, maybe some of these domes, you know, they're not just a couple hundred meters. Maybe some of them are in very large areas. Maybe if the stuff about
kind of like toasty.
Mark, can you mute? Maybe some of the stuff that we're seeing now about the Giza pyramids, where there might be something underneath, maybe that has to do with a much larger like energy dome thing around there, right? Or maybe that thing is taking a natural energy dome thing and it's like increasing the size of it to expand farther. You know, I don't know. There's so much unknowns with these energy dome things that like.
Yeah, possibly. Like the pyramids were mysterious already, and the findings just muddied the waters more. Like, you know, I don't know what to say about that.
It's ley lines, man. It's ley lines.
Yeah, I don't know.
Well, guys, yeah. So we're at about 5:05. We're a little early tonight because one of our presenters wasn't able to make it. Should we wrap things up for today?
Yep.
Okay.
Maybe
well, let me do
today.
some announcements. So, again, I'll close things out by saying visit us online at altpropulsion.com. I have dropped links into chat. This has been one heck of a month, one heck of a spring season, and we're going into summer. We have so much work going on by so many amazing teams in the propulsion community and a ton of new revelations and UAP stuff as well. So thank you to our presenters. Thank you, Orestis. Thank you to Jenny. And thank you to Chad as well. And Jared and Mark, you guys, and everybody else who gave us updates as well. So thank you, guys. This has been APEC for Saturday, June 14th, 2025.